make you the co-host. So, share your slides and we can see if that is also working. Just give us a
Okay. Yeah.
couple of minutes.
Am I audible, Sonika?
Yes, Jyoti, you are audible.
I'm sending a request for you to share.
So we have already informed the technical staff. They are just making you the co-host.
Okay, very good. Is the screen available? Seen now?
Yes, sir.
Very good. Yes. Yeah. Here. One more cup, hot cup. One more. Under this. Tanika,
Yes, sir.
you have full attendance today?
Sorry, sir.
How many are attending?
No, still all have not joined, sir. So
Oh,
we will just wait for 5 minutes because the scheduled time is 10 a.m. So
no, no problem.
it's
No.
9:55. So we'll just wait
Curious.
for a couple of minutes and then we will start.
Okay. See, interesting thing is that if you record the time
Yes, sir.
and the number joining, now say starting from about 9:45 and up to 10:10,
Yes.
okay, and the frequency of how many are joining, it might form a normal curve.
Ah.
No kidding,
Yes,
just
yes.
try.
Yes, sir.
Because some come early and very gung-ho and they turn
Ah,
on. Some, most of them come around 10.
yes.
Something or other, there is they just start coming 10, 5, 10, 10.
Yes. So
So
we
it make it beautiful. Uh,
so that is a good way of recapitulating what we have already done in the previous session.
yeah, yeah. Yeah, see, but basically, this lecture that I'm going to talk today will not make any sense unless they knew the contents of the last lecture on normal distribution.
Yes, yes. No,
Because
sir, I think most of the participants were there in the last lecture, and today also they will be there. So that is
yeah.
not a problem.
So the reason is most of these hypotheses that we test are based on the assumption that the data are normally
Normally
distributed.
distributed, yes.
And we take some of these important properties of the area into consideration while discussing this hypothesis. So that will come into the lecture now.
Yes. Can one of the participants confirm that you, sir, is audible to you clearly?
Yeah, that would be nice.
Well,
Yeah, yeah, ma'am, sir is very nicely audible.
Yes,
okay,
yes,
Very
sir.
good, very good.
okay.
I'm
Thank
so happy. Yesterday's ambiguity and the lack of clarity will not be there today, which is probably good because today is a more important lecture than yesterday's. No. Sonika?
Yes, sir.
Would you like to start the session?
Jyoti, I think we have around 40, more than around 40 participants. We can start. They'll join in another 5 minutes, I so
Yeah.
think so. Jyoti is not there.
Yes, Sonika.
Yeah.
We can
Can
start
we-
now. Yeah. So, a very good morning to everyone. I, Dr. Jyoti Singh, welcome our speaker. It gives me an immense pleasure to extend a warm and respectful welcome to our speaker, Professor T.R. Rao. Sir has already given us enriching session. We are truly honored to have you back, sir. And the topic for today's session is hypothesis testing. So, sir, please, you can start. Welcome, sir.
Hello, everybody. Just let me know if the voice is clear.
Good morning, sir. Yes, sir.
Yes,
Strong
sir.
and clear. Good.
Yes, sir. Voice is clear.
Okay, I'm pleased. Okay, just today's lecture is on hypothesis testing. This is one of the most important lectures I give, and one of the important chapters in a book. So the reason, of course, is this forms the basic conceptual foundation of all the tests we conduct subsequently. Okay, so if you understood this very well, you will be in a very better position to see why we are doing such a test, what exactly is the concept behind it, and how are we able to reach conclusions based on these tests. So try to follow carefully, and if you have any doubts, don't hesitate to interrupt me, and we can sort it out. You know, the scientific method that a scientist approaches is first observation. You cannot get a research idea out of thin air. You have to observe something that should arouse your curiosity. The observation could be out in the field, in a desert or a forest, or it could be within the lab, in a biochemistry lab, or through a confocal microscope. Some observation is made, you have a curiosity, why did this happen, how did this happen? Then you propose a hypothesis, okay? And you would like to test this hypothesis. How do you do that? You could make some further observations to substantiate your hypothesis, or you could just conduct an experiment at the laboratory or in the field and look at the results. The results then will be subjected to a statistical analysis. And that will tell you whether your hypothesis is reasonably right or false. Okay, so this is the procedure we generally follow in any scientific investigation. Minor variations might be there. What is exactly a hypothesis? It's some explanation for the observation you have made. The observation that arose out of curiosity, and for observation, you have some explanation. But in an explanation in trial, that means you want to tentatively offer this explanation and see if there is any statistical proof for it. A hypothesis should be testable and also falsifiable. Testable is obvious. Falsifiable is generally not easy to comprehend what exactly is falsifiable. This is something that is advanced by Karl Popper, and it has become sort of a hallmark for testing in statistics in any area of biology. What it means is this: when there are different kinds of hypotheses possible, you investigate and explore every single hypothesis. You should have a hypothesis that has the potential to be falsified. If it doesn't have the potential to be falsified, that means you are firmly convinced that the hypothesis is correct. Then what's the point in investigation? What's the point in collecting data? So it has the potentially, it is falsifiable, and you propose such a theory that it is falsifiable, then keep on exploring all the things. When you reach a stage, it cannot be falsified any further. Then you accept the hypothesis. That means, has it passed the falsifiability test? Okay, some examples of testable hypothesis and non-testable hypothesis. Is this testable or not? Quick answers. Yes or no?
Yes, sir. Yes, sir.
Because you can look at content in different areas of the state and see the frequency of this morbidity. Is that testable?
No.
Okay. Do you encounter such problems being a scientist and it bothers you? Okay. Is that testable?
No, sir.
Why?
So sometimes we actually pass the exam even if we don't study.
But that could be a hypothesis and to test, and you can disprove it, right? But the problem here is you will not get any students to sort of become your sample. So, sir, please don't, you tell the student, don't study at all. I would like to see if you fail or pass. So it's very difficult to conduct this test. Theoretically possible. Is that testable? You understood the hypothesis? Hello, quick.
So yes, it's possible. It's possible.
It's possible. Okay. The only problem here, of course, is how do you rate pulchritude of a female nurse? That's the problem. This is testable, obviously, right? You can compare the effectiveness or efficacy of drug A and drug B. That is not a testable one. Is it?
No, sir.
Again, this problem is how do you quantify, define and quantify cunningness? If you can quantify it, then you can look at the frequency of these cunningness parameters in hair and hair brother and compare it. Anyways, we have some idea now what are testable hypotheses, what are some fancy hypotheses that simply do not lend themselves to scientific testing. That's again testable. Laboratory testing can be conducted using different intensities of light. Observations that you make for a hypothesis must be quantifiable and objective. If you cannot quantify, there is no statistics. This can be quantified. You can count the number of seeds in the cultivated variety and the wild variety. That's also quantifiable. You can statistics, road fatalities statistics you can gather, and that's a quantifiable parameter. But that's also okay. I mean, you can get the enrollments around July or so, and then see what's happening. But some observations are not easily quantifiable. I'm not saying they cannot be quantified, but it is difficult to imagine how we could quantify them. A couple of examples. In response to this, if the girl says, how much? So she wants to know how much. That means she wants a quantitative statement. So 100.5 or out of 100%, or you simply say, I love you so much, and put the number of zeros after S as an index of how much he loves, we don't know. Here's another example. If she says, really? How terrible. So this feeling of terrible, how to quantify it is not easy. So when you run into situations like this, very often you ask this question, am I able to quantify it? Then only it's meaningful and scientific, rational, objective question. When you set up a hypothesis, you should consider all possible alternatives. This woman gets up in the morning with a splitting headache. You would like to offer some hypothesis. Quickly, can you suggest some? Or is there only one?
Sir, maybe she uh,
Hmm.
watched the screen. She had a lot.
Too
The
long.
previous she had a
Okay.
screen time.
Too long. See, that can be quantified. Yeah.
Sleeping
Okay.
hours, sir.
Okay. What else?
Less sleeping hours.
Less sleeping. Oh, that's also good. Yeah.
In a intoxicated state.
Intoxication leads to headache. Oh, you mean hangover? Uh,
Yes.
all right.
Hangover.
Have you tried or what? Hangover, did you try?
Sir, I
No.
have observed and seen.
Okay.
It is
So
an observation of
all
matlab
kinds
many
of
people around, they say that yes, if they are hangover in the morning, if there is a hangover in the morning,
right.
then
Yeah.
they have a
So
headache.
I can add one more. I will say that she had a very nasty argument with her boss in the office. So, but what if somebody says, "Oh, this headache, you take an MRI, it could be a tumor in the brain." That, according to the doctor and the diagnostics, because they want to make money, they say that no, that is a possible. No, you know. So, when there are different number of hypotheses possible, you should choose the simplest and the most plausible one first. That's called Occam's razor or parsimony principle. When there are so many ways of doing something or saying something, choose the simplest way, and that could be the most plausible one. So, in this case, really a doctor who follows parsimony principle would have simply said, take a couple of strong aspirins or some migraine headache tablet, you'll be all right. Should always consider alternate hypothesis. I'll just quickly give a simple example, just to show how one would go about putting different hypotheses. They both attend biology class every day from 1:30 to 2:30. They sit in the back row seats rather than in the front. Maybe back row seats will give you a chance to periodically sneak into your social media like WhatsApp or Twitter or something. And what's the problem? The observation, they both feel sleepy during the class. Why do they feel sleepy during the class? Hypothesis 1. They had heavy lunch before coming to the class, which makes them sleepy, obviously. I don't know if you teachers have a class at 2 o'clock and all the students from the hostel come back after a heavy meal. You see some drowsiness and yawns. 2, they both sit in the back row seats and there is a less scope of interaction with the teacher. So very often the teacher tends to ask students in the front some questions, in the front benches. Those sitting in the back escape being questioned by the teacher. So they can take it easy and they can feel sleepy also because the teacher is less likely to notice that they're sleepy or dozing off, particularly if the PowerPoint presentation is on. The classroom is too warm with no ventilation. That also is possible. Right? Are there any other explanations? Possible. That a student could feel sleepy? Much as I hate, I have another hypothesis.
Yes, sir. The teacher is not
Yeah,
teaching,
right.
very well. Yes,
Teacher
this
is
one I was
simply,
saying.
the teacher is simply boring. Many of us teachers hate to admit this, but if you take feedback from the students anonymously, you will be surprised at yourself. Okay. So how do we test this hypothesis? They have a heavy lunch before this class. That's why they feel sleepy. Okay. This is the advantage and the beauty of conducting statistical experiments. They can conduct, because they are twins. So it's a wonderful sample to test hypothesis. Future. Okay. Make Vani eat her lunch before the biology class and let Rani take her lunch after the biology class. Now, who should feel sleepy? Vani feels sleepy, but not Rani. Rani hasn't taken her lunch yet. What's the predicted result number 2? Rani should get sleepy during chemistry class, which starts at 2:30. Correct? Because she just came to the class after the biology class after lunch. The twins get sleepy because they sit in the back row seats. Now, this also can be tested easily because one will be shifted to the front, maybe reluctantly, and Vani will continue to sit in the back row. Now, predicted result is Vani will feel continue to sleepy, but not Rani. So, your hypothesis is more or less proved. Like this, you can go. Just think of how do we test the other hypothesis. So you said the fourth one is a teacher is not is not inspiring, is boring. Think of ways how that can be tested. Okay. The major problem with biology, as opposed to physics and chemistry, is there is an enormous variation in any subject you consider, whether it is mosquitoes or bacteria or whales or humans. Enormous variation. This is what we call as genetic variation, genetic variability, the raw material on which evolution acts. And second thing is randomness. Things happen randomly. There is no fixed pattern in which they happen. Anything could happen randomly. This means now, yesterday we talked, or day before, we talked about probabilities of things occurring, events happening. We said for everything there's a probability. That means there is nothing certain about it. Everything could happen randomly. So the uncertainty about it, or the stochasticity as the technical term is, indicates randomness of things happening. Common parlance, we use the word chance. Oh, he passed with high distinction. Oh, come on, he was an average fellow. By chance, he got it. That's all. Lucky he got selected. So the purpose of statistical hypothesis testing is to address these problems and see how to get out of these two possible problems and come up with plausible conclusions. Okay, some of these hypotheses that we can nicely set up and test. Oh, that's a gender sensitive statement. Do boys agree to that?
No, they would not.
They would not agree. But you should assertively say, no, sir, this statement is correct. I don't know. This sometimes I put this in many lectures and try to get sort of a general idea about how they feel. But if you ask my experience, girls were doing better in all these 40 years on the average. Statistically significant difference. Okay, so you have a hypothesis and all this now. So I'm just taking a fictitious example to show where we run into problem. There are two tribals living in the lowlands and one isolated population living in the hills. The only difference between these two tribes is the hill people, they seem to add some special herb in their diet, which is not growing in the lower regions. Okay, so, and they have also observed, this is fictitious, they have also observed that there is a frequency of certain type of cancer, pancreatic cancer, is different between the hill population and the lowlands population. So the clinician or the researcher thinks that there might be something in the herb that the hill people eat that might have some cancer suppressing property. Fair enough. It's a plausible hypothesis that can be tested. So you conduct tests on induced cancer laboratory mice, and one will be control, whose diet does not include this herbal extract, and the other one which includes this herbal extract. We call it treated, the other one is control. Let us say the result is like this. In the treated group, cancer cell growth was inhibited by 15%. Wow, there is something. You simply say, looks like this herbal extract might have some good effect on the cancer inhibition. Are we justified in reaching this conclusion? Why do you ask? I say the effect of inhibition is only 15%. It's just 15%. It's not 40, 50% or something, suppression. Just 15%. And we say, come on, is it not possible that just 15% difference is just due to chance alone? Just randomly it happened because you took a small sample size. From 20, let us say, you took to 200. This difference might come down to 5. What if you took 1,000 sample size? And statistically, the difference will keep coming down. Then suddenly there is no difference. So when you get a 15% inhibition with your sample size, are you justified in thinking that this herbal thing has some beautiful, wonderful properties of inhibiting cancer cell growth, and then start trying to commercialize it? So at what point do you think or conclude that it's good enough, the effect is good enough that it can be commercialized? If I say 15% is just randomness, by chance it arose the difference, 10% also. If you say 20%, now you say, no, 20% is good. What is good? I say, unless you prove it's 50%, you cannot. So you see, the argument leads to the fact, at what stage of this variability or randomness do you say it's way far above the randomness and showing significant effect of the treatment? That is the question. That's an important question anybody would ask in any type of research when you are comparing a control and a treatment. So that question was addressed by Ronald Fisher. Anybody who is into genetics, population genetics, evolution, and statistics will not be forgiven if they don't know Ronald Fisher. He is one of the founding fathers of a field called population genetics, which combines fields of genetics, Mendelian genetics, with evolution. He was a giant of a statistician who addressed this question and tried to come up with some answer. The answers he proposed come under a statistical testing procedure called null hypothesis significance testing, simply abbreviated as NHST. Actually, he is one of the 3 important people who came up with this: Neyman, Pearson, and Fisher. Okay. What does it say? That's what this says. His hypothesis testing, he tries to answer. There is a conditional probability, P, that will indicate whether the observed effect is due to chance or more than chance. Okay, this is the P that we talk about so many places in research statistics. Oh, P is less than 0.5, P is so and so. You ask a lot of these students, PhD researchers, postdocs, whoever it is, what exactly is this P? We'll try to answer that. First of all, let's learn some basic methods of proposing or setting up a hypothesis and the symbols that are used. So I'm just taking 4 hypotheses. The hypothesis, null hypothesis you set up is like this. In other words, if you think there is a difference, you have to propose a null hypothesis. That means they do not differ. Okay. That's why it's called null. Null means zero, no. So we are testing the mean values of in the parameter. In the cancer cell inhibition, we are talking about the percent inhibition, which is the average percent inhibition is mu of the two groups can be compared. So here it is males and females. We put a subscript symbol so we know what we are talking about. Remember, actually what the hypothesis you want to test is about the values in the population. And you are testing this with your sample. So there should be some way of testing if your null hypothesis can be proven right based on your sample values. This is another way of doing, right? So you can see the pattern, null hypothesis proposition. Okay, and there is another thing you have to learn. Suppose we take this hypothesis, males and females, and normal curve for each set of observations. So this is where you are saying they differ. If there is no difference, it will be zero. So you are saying there is no difference. But you are not saying if one is better than the other. Right? So this is a two-tailed hypothesis. Your hypothesis will be proved or disproved if it is less than or more than, doesn't matter, as long as it's not equal. However, you can propose a two-tailed hypothesis. Here, whether it is less than the population mean or more than the population mean, it's the same. This is called the two-tailed because it is concerns the values below population mean and above population mean. However, you can propose a one-tailed hypothesis also. Your null hypothesis could be this. Okay, I know from my intuition or whatever that women have higher cholesterol levels. Then I might as well propose a one-tailed hypothesis. They're equal to or more than. Then you can disprove it. That's called one-tailed hypothesis. So you have two-tailed hypothesis when you are only looking at the difference. You are not concerned whether it is more than or less than. Sometimes your initial observations give you the idea that one of them should be more, right? So then you propose it one-tailed hypothesis. The reason we have to be selective about this before we start the collection of the data or analysis is that when you read the probabilities for one-tailed, you have to half the probability because you are concerned probability only on one side of the curve. You are following the logic, hopefully. Say yes. Does it take so long to say yes?
Yes, sir. Yes.
Yes, sir.
Sir, I didn't understand this. If
Yeah.
within the same age group, women have higher cholesterol levels in men, then how the value of mu is less than what is?
No, I said it's null hypothesis. That means you have to propose the opposite of that, and so we can. You see, you cannot accept a hypothesis. You can only reject a hypothesis. We'll come to that later. Huh? So if you want to reject something, you have to prove the opposite. When you reject that, you are simply saying yes, women are have more cholesterol.
So we are starting with an assumption that the mu W is less than.
Yeah, right. Okay, or equal to.
Okay.
Sometimes it makes sense to distinguish a statistical testing procedure and a scientific testing procedure. This example. What does statistical thing do for this kind of a hypothesis? It tests you whether the differences are significant or not. There ends the matter. Then you have to ask the scientific question, why are there differences? So that's where your scientific investigation starts. Why is seed number different? hypothesis. Soil A has higher nutrient levels than soil B. Higher nutrients means, better production, maybe higher number of seeds production. Then you measure nitrate and phosphate levels in both the soils, conduct or field or laboratory experiments, and prove your point. This is scientific method. Statistics doesn't answer the question. It will tell you if the observed differences are truly significant or they arose by chance, randomness alone. So this is very important to realize. We are always testing what could be the population value because we are not able to sample the entire population. If you have a fixed number of individuals in a population, it's easy. If somebody is trying to take some important parameter account in, say, Ranthambore National Park for the tigers, there might be a fixed number of tigers for which you can collect this information for every single individual. But if you want to estimate the average number of eggs produced by a female mosquito, you will never know the population mean because there will be billions in Delhi alone or Hyderabad alone, right? So you are only hoping I will take what I constitute as a random sample. I use my parameter to estimate the population parameters. So your sample mean by bar is trying to estimate the population mean mu. And these things, you can see that standard deviation for sigma, okay, and then sigma square for variance. This you should keep in mind. We see how true our sample values will be to say confidently that these should be the population values. To give you a quick example, in your college, let us say you randomly catch hold of 3 students. Okay, near the cafeteria or wherever. Okay, these 3 students happen to be males, let us say. You ask them, who is your favorite movie actor? Oh, I don't know. They will say Alia Bhatt or Deepika Padukone or somebody. All 3 of them say that, okay? Deepika Padukone. Now, this is your sample conclusion that the entire college male population has preferentially vote for Deepika Padukone or something. Are you justified? So your small sample should allow you to make a grand statement about the entire college male population. So that's the crux of the problem. So since you don't know the truth, that means what is the actual value of the college, you are likely to goof up. Accidentally, you got 3, all of them liking that particular star X. You are likely to conclude the whole college goes all gung-ho for X. You went wrong, right? So these things happen in any investigation, whether you are investigating cholesterol levels or some genes or some populations in national parks, etc. So I repeat this important thing. The truth, which is the real population value, you never know. If you knew it, there was no sampling necessary, there was no statistical treatment necessary. You simply say this is the value. All tigers in India will have exactly this value for their heartbeat. But you don't know when the populations are big. So when you don't know the truth, your sample might lead you to make errors. Okay? That's the most important thing for proceeding further. What are these kinds of errors? In any hypothesis testing, there are 4 types of conclusions possible. This refers to some drug effect on serum cholesterol, so let us say. The drug really has an effect. That means it's a population statement. Okay, the drug really has an effect. And the study also finds the same. Good. Our sample correctly estimated the population value. Our Y bar correctly estimated mu. 2. The drug really has an effect somehow, but our study concluded it didn't have any effect. It's possible, maybe chance alone, or the small sample size, what have you. So this made you conclude that it has no effect at all, but in fact, in reality, in the population, it does have an effect. Third one, obviously, the drug didn't have any effect. And your study also reached the same thing. That means using a small sample size, you were able to show that even in the population values, the drug has no effect. Good. 4, it has no effect at all. The drug has no effect at all in a population level, but the study concluded that it has an effect. Chance, random effects, small samples, etc. So, 4 possibilities, right? So you can list like this. Drug effects and your conclusion. Right? You understood this table? So now ask questions. In which of these 4 possibilities did our experiments help to prove and reach the right conclusion? Right?
The first one.
First one. And what's the correct one? Second one.
Third one should be correct.
Which one? Third one should be correct because both agree.
Third one.
It's the correct conclusion on your sample. Okay. 2 things we made a correct conclusion based on our sample. We somehow picked up on the exact truths by using our sample and doing some statistical testing. 2 things we could have gone wrong. Right? One is number 2. What is the error we made? क्या गलती हुआ है?
So maybe the studies means having some sample test or lab test. Maybe something went wrong.
No, we are not asking for an explanation. What the errors that have occurred is, number 2, you know what we did? We rejected a true null hypothesis.
Okay.
True null hypothesis, it had a real effect, the drug. But you concluded it didn't have any effect. That means you rejected the null hypothesis, right? Now 4, what will you say? Here, it has no effect, but you concluded it has an effect. So you have accepted a false null hypothesis. You see the distinction between these 2 errors? It's very important. Tell me. Is it understood? Is that clear?
Yes, sir. Yes, sir.
Yeah, this is very, very important. Make sure that everybody understands this. Okay. So, number 2 is the error made is error of rejecting a true null hypothesis. This is called type 1 error. In statistics jargon, this is type 1 error. When anybody says type 1 error, you know exactly what they're talking about. We called it type 1 not because I started with this first. Even if I told this later, after 4, it still will be type 1 error. Type 1 error refers to the alpha. Okay, it's referred to as alpha, the error. And we'll come to that what alpha type 1 error is quantitatively, if we can quantify it. The 4th one is error of accepting a false null hypothesis. And this is called type 2 error. Right? And this has a symbol of beta. If somebody talks about beta error, you quickly know what they're talking about. That's important. When you get some statistical sort of feeling or familiarity, And these two will be common if you go to meetings or conferences, somebody talks a lecture and say, oh, I try to minimize beta error. They will say. But in my experiment, type error was very low. Alpha was very low kind of things. So you should not be wondering, what is he talking about? You should quickly come to your grasp. Oh, he's talking about what is the probability of causing this type of an error, which is rejecting a true null hypothesis. Okay, so this should be very clear. So we are going to give an example. First, we'll talk about an example from a judiciary. A judiciary system, which probably is not there in India, where the accused is tried based on jury's recommendations, jury's verdict. Must have seen some 12 Angry Men, some Hollywood movie. There must be some Hindi equivalent for that, I forget. Where a jury comes to a final decision whether the accused is guilty or not guilty, and conveys this verdict, jury's verdict, to the judge, and then the judge reads out. So let us say we start with the null hypothesis, which makes sense because in most judicial systems in the world, the accused person is not considered guilty until proven guilty. Okay, in the court. So it's fair enough to say null hypothesis, he is not guilty. Now, here I want you to watch the terminology, the words we use, the phrases. We are saying the person is not guilty. We are not saying he is innocent. That distinction is very, very important in statistics and in the court. Okay, so they appoint a jury. So this could be true or false. We don't know if this person is brought here. We presume, the court presumes that he is innocent or, sorry, not guilty. It could be true that he is not guilty, but it could be false that he is guilty. Only truth will come out when arguments start. Prosecution and defense attorneys. So jury is appointed. At the end of all the arguments, juries can come up with a verdict saying either guilty or not guilty, right? Two possibilities. Okay. Now, so there are 4 squares now. Carefully, where do you give the green mark? Or you can simply say, where is type 1 error, where is type 2 error? Think carefully. Just see, compare the column title and the row title. Guilty, true, guilty, false, true, not guilty, false, not guilty. Come on. Person is truly not guilty. And jury also came to the same conclusion. Right?
Sir, fourth one should have some error and the first one should have some error. Alpha,
Yeah,
beta, I'll recognize.
true. But let us first get the correct ones. Here,
The guilty false.
the person is not guilty null hypothesis, but that is false. That means he is guilty. And jury also found it guilty. So that's also a correct verdict. So errors must have occurred here in this, which is wrong, and this is also wrong. Agreed?
Yes, sir.
Okay.
Yes, sir.
So now, which one is type 1 error in these two?
The blue one, type 1.
Number
One or this one?
number two is alpha. Number
Alpha.
1 is beta.
This
Number one is beta.
Beta?
Yes, sir.
Number 1.
Yes, sir.
Let's see. This is type 1 error. Because he is true, that means he is not guilty, but he found it guilty. the jury rejected a true hypothesis, right? And here he is guilty, okay? And he said not guilty. So accepted a false null hypothesis. So this will be type 2 error. Okay, so one more example from clinical point of view. So we know that these two errors are called alpha and beta. Now we'll just quickly look at a clinical example. A lot of patients go to test AIDS. So the null hypothesis that he has AIDS. So we have diagnostic tests that will show whether he's true or not. But you know the test cannot be 100% correct. So it could be negative or positive. Right? So if you look at, I didn't put the squares here, A, B, C, D. Okay? Where is type 1 error occurring?
In the first row, second column.
This one.
Yes.
False. Okay, that he doesn't have AIDS and you diagnosed as having AIDS. Okay? Now I show these things. A 1 minus alpha proportion of patients with AIDS are diagnosed correctly as having AIDS. Alpha proportion were diagnosed wrongly as healthy. So this must be one error. Beta proportion healthy patients were wrongly diagnosed as having AIDS. This is correctly diagnosed as healthy. So that's it. Right? Okay, just mull over this, so you can see, again, try to follow the logic, the argument behind it. So here, you know what happened is, this fellow, okay, he is healthy. He does not have AIDS. But unfortunately, the test came out positive. Okay? He will go home and have a miserable time convincing his wife that he didn't do anything wrong. But basically, this is a false alarm. Right? You agree it's a false alarm because it showed that ringing the bell, you can say almost that it is positive. It's a false alarm. There was no AIDS at all. So, same thing, can you name this one type 1 error comparable to this one? What would you call that? Yeah, try to come up with. A lot of times my students fail, a lot of them fail to come up with a nice suggestion. What you would call?
Wrong diagnosis.
No, something to match with this one, that one. False alarms.
False diagnosis.
No, I'm not talking about diagnosis. That is clear, it's false diagnosis, but false alarms and
True health. False healthy.
you know what I call this as? Failed alarms. You should have rung the bell clear and loud that he's positive in a test, but he was diagnosed as healthy. Okay, so just terminology. Okay, so which one is type 1 error? Which one is type 2 error? A is come on, it's too obvious. A is which error?
Type 2, sir.
Like false positive.
And this one? Rejecting a true null hypothesis. She is indeed, unless it's gas, it's just she is indeed pregnant, right? So, but she is rejecting that. So, type 1 and type 2. Okay. There are two more statistical parameters and also used in clinical side are sensitivity and specificity. We'll use the same diagnostic test for AIDS thing. Sensitivity refers to a patient should test positive if he has AIDS. Every positive patient to test positive. Everyone who has AIDS should come out positive with your test. Specificity means it should come out positive only if he has AIDS, and for everything else, he should come negative. That means if he is healthy, it always should show negative. Okay? These two parameters. So, the question now is, where is sensitivity in these four squares? Where is specificity? Every time a patient has AIDS, your test should come out positive. Okay, that is sensitivity. You should come positive only if it is AIDS. For everything else, you should come out negative. So, come on. Anyway, to save time, okay? So you can talk about in a numerical problem about sensitivity and specificity. Just quickly read. You may not be able to do the problem, but I'll show you how it is done. See, the test, diagnostic test, it has a 95% chance of being right. That is sensitivity. We say it's a highly sensitive instrument or kit. And if it's absent, it should not show positive. That is specificity. So there is a population in which 8% are supposed to be coming for the test, okay? Now we ask this question, what's the probability that a randomly selected person from this group will test positive? You can construct a probability tree. 8% has the disease, 92% doesn't have. Okay, because 95% sensitive, right? So, if you look at now, this is positive, the true positive, and this is false positive. True negative, you can see that, right? So if you randomly chosen person, the probability of having a positive, okay, is true positive plus false positive. So about 17% of the population will be diagnosed as positive. Of those 17% will be truly positive, and 7% or 9% will be false positives. There are too many false positives. Okay. How much type 1 error should we allow in testing our results? Knowing fully well that errors are possible, type 1 error especially, without knowing what the population value is, we might be rejecting a true null hypothesis. So, and nothing is 100% normal distribution, we know that, right? So we'll simply say, okay, if we have, say, 5% error, that means the 5% of being wrong in rejecting a null hypothesis, it's okay. Or you would say 99% if it is some clinical side. But you have to specify, and the amounts you specify, that willingness for the type 1 error, okay, is an important factor in testing procedures. General procedure all over the world is they allow no more than 0.05 probability. That means 5% error. Okay, so 5% of the error they are willing to let go, be wrong. But they say 95% of the cases, our null hypothesis should come out right. That means our null hypothesis should be exactly the same as the population null hypothesis or population hypothesis. Now, question is, do we fix that alpha value? As I said, the rule of thumb most people follow is 0.5 or 5%. So alpha refers to 0.5. But you might simply say, no, I can't even afford to let go 5% errors. And maybe if it is a very critical clinical tests, then you might want to fix alpha at 0.1, only 1% of being wrong in rejecting a null hypothesis. Is it clear? Type 2 error is not generally in your hand because you don't know what the alternative hypothesis is. Only if you know the alternative hypothesis, you can say that, well, that should have been the hypothesis. This one is false hypothesis, which is true hypothesis, which you don't know. Generally, it's very difficult to set a specific beta error in your experiment before you start. However, there are methods of doing it, which we won't go into in great detail. So we cannot generally fix it, but it can be tried. I will show you how these two errors, alpha errors and beta errors, are related. Sonika, at this stage, can we take a 5-minute break for the benefit of the participants, not me?
Yes, sir, definitely.
Okay. Let us meet exactly in 5 minutes, so we can try to finish by 11:30 or so. Okay.
Okay, sir.
Meanwhile, you can relax or ask me some questions, statistical or otherwise.
Participants, you can take a break from the presentation, but sir is available for any queries if you have.
So if you want, you can quickly browse through your WhatsApp, Instagram, or what have you.
Sir, actually, it is not a statistical question, but I am just interested as the example was taken of this particular case. An accused person is considered innocent until found guilty.
Okay.
So most of the juries across the world followed this, and till 2018 or 19, we were also following this. It has been a recent amendment in 2018 or 19, if I am not wrong, that we have meant the accused person is guilty until found innocent.
This is against the judicial legal requirement, but actually there is a joke about in some country a person is considered innocent until found. If he's absconding, you find him and you find him guilty. So basically, no, the thing is, it's not fair to assume that he's guilty even before trial is done. Because the defense people should have a chance to prove themselves. Even before that, if we have already preconceived notion he is already guilty, there is no meaning in conducting a trial.
But we have recently amended this 5-6 years back.
Yeah, but you see, it is for the legal experts to judge which is better system. In the US, where I have been, the jury is selected so randomly. You know how they used to select?
No, sir. No, sir.
Those days, a telephone directory of the city they use. Now we don't have telephone directories, but they used to have telephone directory where every citizen's telephone number is listed. They take randomly a telephone number, look up that person and inform him, sir, you are selected for a jury in this particular case. So 12 members are selected so randomly. They don't know who they are, telephone directory, they haven't seen the person, just choose a name by alphabetical order or by phone number, select it. Once I know that our neighbor was told me that he was called for jury duty. Oh, I said, oh, that's great. But you know what he was? Barber. He used to do my haircuts. So it could be anybody. It could be a professor in Harvard University, or it could be an auto operator or a taxi driver. They randomly select. So that's the beauty of the system. I don't say it's completely faultless and perfect, but that is the system they have. Okay, anyway, that's not for us to judge. If any of you are planning to go into a side degree besides a science degree, a law degree also, you might be interested. Okay, so is the 5 minutes over, Sarika? Shall we reassemble?
Yes, sir.
Keep an eye
Yes,
on the watch. Yes, we can start, I think, because nobody has left the meeting. They are here.
Okay, yeah, okay. Well, if they left the meeting, you won't know. It's online.
So we'll look at the number of participants.
Yeah, but they can just turn it up.
Yes, if they're not physically there, we can't make out.
Right, exactly. I used to have this problem in Mohali, I would see that all the class students have come, and periodically I suspect they are not there. They are attending to something, cutting vegetables in the kitchen or looking at social media somewhere else, etc. So randomly, I choose a student's name and they call out and say, "What did I exactly explain to you 1 minute ago?" Then I don't get an answer. Then I know she was not there. So this is no, actually, it is online has some peculiar problems that you try to circumvent. How to see, Other thing is, if you have small group, most classes they insist that all videos
They have
must
their
be
camera
turned on, and I
focus.
can see them what they are doing, whether they're attending or not. So
Yes,
the
sir.
possibilities are there. But when you have 60, 100, 200, you leave it to their conscience and simply say, "Well, I am teaching you something."
Yes, sir.
sir,
Let
that
it-
means the number of joinees, not attendees, is giving us a false positive.
Yes.
Exactly. Now you are beginning to start that statistical terminology. Yes, this is true.
It is giving us a
Okay.
false positive of
And
that there are 59 participants in this meeting, but they are
okay.
participants, not attendees.
And you can go further in doing some tests. You look at the difference between number actually there and supposed to be and their actual number participating. See the difference is related to the type of the teacher or topic. Okay. If the topic is not very exciting beforehand, they say, okay, I'll just put my attendance and go. So this also might depend upon the speaker. It might depend upon the variables, different variables. So you should not
But
jump
it
to the
might be because of the topic interest also of
right.
candidate.
That's what I'm saying. So topic, the title of the topic, and the teacher who is teaching. If you already know about this, some particular teacher X who is supposed to induce you sleep, you say, I would rather stay back. I'll just put my attendance to show that I'm participating, but I will not be interested. All kinds of things are possible. Anyway, but here the situation is very different, I hope, and all are attending. Okay. So we'll move on to the relation between type 1 and type 2 errors. Follow these graphs carefully. So we are now to illustrate this idea of two errors. We have to think of a situation where there is an alternate hypothesis. In real life, you don't have an alternate hypothesis. Okay, suppose now you say the average heartbeat of adult human beings is 72. If it is not, what's your alternate hypothesis? It should be 90 or it should be 45. This is the dilemma a Martian from outer space will face when he comes to Earth and say, I want to measure their heartbeat. He can take a sample, but what null hypothesis would he propose? He doesn't know the normal heartbeat of adults on this planet. He will arbitrarily go something and okay, based on my experience in planet Mars, I'll say the normal heartbeat is 120 or 150 or even 200. If you get 200 heartbeat, you are in a hospital, not in your statistical sample. So The idea is that we don't have, but here for theory's sake, I'm proposing an alternate hypothesis. I'll call it a B. Okay, I will come to that B. Now here, the important point is we chose a p-value alpha error. Now you know the terminology, what this means. Mentally, you should imagine 5% error. We are accepting 95% and say 5% error TK. So 95% is the acceptance region. Okay? And the other 5% spread equally, say 2.25, 2.25, whatever, is the rejection region. Is this clear? Okay. Arbitrarily, I gave a standard deviation of 4. Okay. You can see that 1, 2, 3 standard deviations on each side. Now, obviously, this is 95%, 2 standard deviations on each side. Remaining part of the curve can be divided into 2 halves. This one is a rejection region of alpha by 2, right? This also. So together they form 5%. I could have put 2.5 or something like that. I just put alpha by 2, and this will be all acceptance region. Okay. Now let's go to the alternate hypothesis. Okay. Here the proposal is that null hypothesis could be, we don't know, but we are thinking, let us say it could be 42 instead of 30. It also has its own 2 standard errors, deviations, it also like this. And it has its own acceptance regions. Okay, now carefully check this now. If you put 2 standard deviations on each side for this, okay, this particular part of this curve, follow my logic, falls into the acceptance region of the curve A with mu as 30. Correct? Rest is out. This so happens that part of the curve falls into the, not the rejection region, then it doesn't matter. It falls into the acceptance region of this group with mu 30. Okay? And this percentage of the people in this group whose mean is 42 are being accepted by this group as acceptable, right? Because it's in the acceptance region. So this obviously is beta error because this is accepting a false null hypothesis. Agreed? Are you following this?
Sir, for the curve A, which we are writing the mean value as mu A, the whole from 30 to 34, 34 to 38, whole region will be
so see,
taken as
42,
an acceptance region?
48, 34, 2 standard
Right.
deviations.
Yes,
2
sir.
standard deviations on each side. I'm just ignoring that.
Okay.
So if you take 2 standard deviations up to here, so that is, for this it's okay. Now accept that acceptance region is falling into this acceptance region of the first hypothesis of mu 30.
So 34 to 38 is the acceptance region for both.
No, see, right. So 2 standard deviations is acceptable for this the blue hypothesis, right? Blue curve.
Mm-hmm.
So this will fall into this part of the acceptance region. And so this red marked triangle also is the area or the percentage of the individuals of group B that are falling here and taken by the group A, that they are also part of this system. And now we are committing this error of accepting a false null hypothesis. Because this red part is null hypothesis 42. It's a false, not in this purview. Which means we made an error, which of course obviously is a beta error. Okay? So you can see how beta error relates to the acceptance regions. As I said, I repeat, you never know what the alternative hypothesis is. But you would like to minimize the beta error. You would like this to go away as far as possible, so this will be less. Okay? There are ways of doing this, although you don't have an alternative hypothesis, which I won't discuss for this lecture. So this is the concept of beta. Okay. Now, what is the remaining part of this curve? Alphabetically, algebraically. What this part? Come on. Simple algebra. If this part is beta, what is this? The remaining.
1 minus beta.
Right. It's 1 minus beta, of course. Right? Now, let me go back. This is 1 minus beta, this part. Can you describe in words what is 1 minus beta?
Sir, it is.
Can you describe this now in words? What is this 1 minus beta? It is the false hypothesis that you don't let it to come into your hypothesis. Correct? So, the smaller the beta value, follow this. The smaller the beta value, the larger will be the 1 minus beta. Agreed? Yes?
Sir.
Yes.
Yes,
Okay.
sir.
So,
Yes, sir.
1 minus beta refers to percentage of false values, okay, that you reject. These are false values that you accept. So generally these are the, so the more you reject false null hypothesis values, the better is the test. Okay. So this particular portion of the beta, B curve, the red one, excluding the beta error that falls into the acceptance region of the blue curve, is a measure of the power of the test.
तूने कितना खराब काम किया ये सब उठा रोटी के तिनके हैं चादर अभी बिछाई थी सब.
Nice break from the statistical routine. Okay, so the higher the value, this one, the lower is beta. Agreed? The higher the
Yes,
beta,
sir.
the lower is 1. This means now you would like to keep this red values, percentage values, as low as possible and this part as high as possible. Okay? That's why this 1 minus beta gives a measure of the power of the test. Okay? Now, if you set this error acceptance region at 0, 1 instead of 0, 5, we have seen what happened when we set it at 0, 5. Okay? Acceptance region. So this alpha by 2 and alpha by 2 on this side, each is 2.5% approximately. Now let us say you are very finicky and very particular that you want to say, I want alpha error only at 0, 1. That means only 1% of being wrong in rejecting a hypothesis. Then see what happens. This acceptance region has widened from 95 to 99. Everything else remained the same. Now the beta error has increased compared to this and this. You follow this now? Is this very clear? This is something over the years I have sort of perfected to give you kind of an explanation. And many people follow it. I hope you follow too, the logic behind it. So when you set this error, that's why I put one below the other. So you can see comparison. What happens when you change your alpha error from 0.5 to 0.1? See the difference? That means the lower you set your alpha error, the higher is likely to be the beta error. The conclusion is alpha and beta are inversely related. So when you set it 0.5, you think it's okay, I should come out right. But you get over ambitious and try to reduce this rejecting true error kind of things. And then you go to 0.1. Without your knowledge, you might be increasing beta error. So a sage advice, a sober advice is that as far as possible, 0.5 is fine. Don't go to 0.1 or 0.01. You will be unnecessarily increasing beta error possibility. That means you'll be accepting more and more of false hypothesis values. And so 0.5 is generally recommended, but there is some discussion about it. I don't have time to go through. There is a lot of controversy. Why P is equal to 0.5, we have to decide. Who decided? Ronald Fisher? Fine. But why can't we change according to our own laboratory experiments? So they don't think that 0.5 that is set P value, the probability value of error, being 0.5 is nothing sacrosanct sacred about it, that you can change it. So there is a lot of controversy about it. Many people say, junk it, set up your own values, etc. With all kinds of logic. But for now, time-honored tradition that 95% of the people follow is what's called the NHST, null hypothesis significance testing, in which this gold standard is taken as 0.5 alpha error. Okay. Occasionally, as situation demands, you might go to 0.1, but be aware of possible increasing beta error. Okay. So you can see that these two are related. Smaller the alpha, greater is the probability of accepting a false null hypothesis. So higher is the beta. Okay, so that's why 1 minus beta is a measure of the power of a statistical test. When somebody says, I want to choose a very powerful test, you hear statisticians often boasting or saying, look, my data is so complex, I just want to take a very powerful statistical test. I want my test to be very, very powerful. So actually, in their mind, they are thinking, I want to minimize the number of false errors, whatever into this. And that means you want to reduce beta so that 1 minus beta will be higher. That means it will be more powerful. Without knowing what an alternate hypothesis is, it's very difficult to judge what it could be, beta error, right? But people have taken a roundabout way and say, I will choose arbitrarily a beta error of 0.8. Okay? 20% of false things coming into my thing is okay with me, but no more than that. So beta error of 0.8. That means power of the test is 0.8. In order to achieve this, you have to do some juggling around with, particularly with sample sizes and setting up your alpha error. Obviously, if you set up at instead of 0.5, if we set up at 0.1, your beta error is increasing, 1 minus beta is coming down. So it will be less powerful test. Correct? So you have to judge, because there are some people who say, I will use only 0.1, which is 10% instead of 5%. So there, the encroachment of the other curve will be less. That means the beta error will be less and the test will be more powerful. This kind of manipulation is best accomplished by changing the sample size. Okay. Okay. How it is changes with the sample size, you have to go back to your normal probability distribution thing and see where sample size comes in what statistical parameter. Okay. So we come up and estimate the final part, another 5 minutes. How confident are we in our estimate? You see, based on your sample value, or let's say for our very first example, 15% inhibition. Okay. Can you confidently say the effect of this herbal extract is to affect a 15% inhibition in cancer cell growth? Right? How confident are you about this estimate? If I ask a 12th class student, how many marks are you expecting in your physics? Okay. He will say 85%. You know what he is doing is he is giving a mean value, sample value for himself. I repeat the question and say, sure, 85%. Then he will fudge a little and simply say, uncle, it might be, say, between 80 and 89, something like that. His original estimate 85 falls into this, but he's now giving two limits in which his prediction should come out right. These are called the confidence limits, because he is able to mention with confidence that I should get between these two. I will not be able to say exactly I'm going to get 85%, but I'm going to say it should be definitely between 81 and 89%. Even pollsters, come elections time, pre-poll sampling and all those things they do, right? They say this guy will get, this candidate will get about, he won't say 45% votes. They will simply say he should be getting between 38 and 50% votes. So they are giving a confidence interval for their estimate. How do we calculate that confidence interval? Now, in this, of course, we come back to the basics. We know that this is the acceptance region. So these are the critical limits. You can define in your confidence limit in terms of these critical limits, because you are saying that 95% of this thing, my estimate should be correct. The number of marks I'm expecting should be correct. It should be correct. So these are called the critical regions, critical values. 2 standard deviations below the mean and 2 standard deviations above it. And these will define the lower and upper limits of the confidence interval. So you can calculate confidence interval using sample values. This will be this. Those two standard deviations on each side, 2 standard errors, because this is a formula for standard error, remember? On each side should be our confidence interval. Why are we using 1.96 instead of 2? Did I make a mistake? Huh?
So Z score at 95% at 1.96?
No, it was supposed to be 2. Why is it 1.96? We said 2 standard deviations on each side. Okay. If you go back to your curve, we said 2 standard deviations cover 95.5% of the values. So to make it exactly 95% instead of 95.5%, we reduce this 2 to 1.96. You follow this now? So now, suppose we want to be more confident. How could you be more confident? You say 3 standard deviations on each side, correct? Then your acceptance region is growing. So we say 99% confident then instead of being 95. So we use the formula, same thing, but this number will change. Because instead of 2 standard deviations, we use 3. Correct? There you go. Again, curiosity is, why are we using this 2.57? Come on. From the top one, you should have guessed this one. 3 standard deviations on each side of the mean cover 99.9 something of the values. But we want only exactly 99. So instead of 3 standard deviations, it becomes 2.57 standard deviations, standard errors on each side will take care of exactly 99% values, not 99.5. That's why we put 2.57. Okay, so these two are used depending upon which you want. 99% confidence or 95% confidence, you use this number. Then you calculate standard error. Now, it's better, another 5 minutes, please. You want to reduce the confidence interval. People become more confident and they trust your estimate better if your confidence limits are narrower, the interval is narrower. To give you an example of this time, standard 12th student, he says 85. I asked him, how confident are you? If he says from 75 to 95, as opposed to 81 to 89, which one would you believe? He seems to be very sure of himself, how much he's going to get. So I think I better trust 81 to 89. If a candidate asks the pollster to get a survey of how people are feeling, how many votes he's likely to get, he comes back and says, sir, you are likely to get anywhere between 30% and 50%. Is there something to rely on? The candidate will simply say, hey, come on, guys, I want more precise estimates so I can decide. So the narrower the confidence limits, the more confidence you are likely to get. So if the pollster said, sir, you are likely to get between 45 to 48%. Wow. Then you say, wow, that's worth taking a chance. Okay, and get into the fray. So the idea is, everything else being equal, how to reduce the confidence interval. You can see how we do that. You know that you can't change this number. Okay, either you have 2.57 or 1.96. This is your mean value anyway. So you can only change this value. So the smaller this value is, the narrower the confidence interval. Agreed? Simple. How to make this narrow?
So
Small
increase the number
value.
of increase, and that means we have repeated observations.
You increase standard deviation, decrease standard deviation, okay? Or increase sample size.
Increase sample size, right?
Pardon me? Is there a third thing?
Sir, increase the sample size and
Yeah, sample size. Increase the sample size, decrease standard deviation.
Yes.
Is decreasing the standard deviation is a question of variability in the sample. Normally, you would simply say it's not in my hands how to decrease standard deviation because it's a part of the genetic variability of the sample I have taken. But if you are very careful, you can choose the individuals in such a way that the variability is reduced, standard deviation is reduced. How do you do that? Suppose you're sort of looking at some effect of some drug on heartbeat and all those things. You have to specify the age group. So you will say, I'll take 40 to 45 age group. But if you include some children and some really old people, naturally the variability will increase. Suppose males and females have a way of responding differently. mice, for instance. In the laboratory mice, if you take a sample, ignoring the difference between males and females, there will be a lot of variability. Standard deviation will be high. Then you say, I will select only one gender. All individuals in my sample will be males only. That's not gender discrimination. If somebody says that, you'll simply say, no, I'm going to do the next experiment taking all the females only. Don't worry. So one way to do is to make it your sample as homogeneous as possible, within the limits possible. Now, second thing is in your hands. Sample size can be increased to reduce confidence interval. Okay. So sample size how can reduce? Well, depends on what sample you're working with. If you are working with fruit flies or mosquitoes or even small insects, you say, no problem, guys. You want me to increase to 1,000, I'll do it. If you want 2,000, I'll do it. Don't overdo it. But what if you're working with, say, rhesus monkeys? To increase the sample size is not easy. With great difficulty, you might get 4 or 5, that too taking so many permissions from government and all those things for research. God forbid if you are asked to do some experiments on elephants, your sample size could be no more than 2 or 1. So, sample size as far as possible, try to increase, but not overdo it. Because there are animal rights activists who want to keep an eye on you to see that you are not unnecessarily killing or harming animals. Okay, so they might come upon your lab and start making dharnas and protests and publish nasty articles in the newspapers. So with justification, you take an optimal sample size, not too big, not too small. They say take an optimal sample size. There are some, and whoever is going to give a lecture on sampling methods will probably discuss more on how to optimize the sample size you would like to take. Okay. So this is how one would plot a confidence interval for an estimate. Okay, sample size here, 2 standard errors on each side, or 1.96, whatever. But these are called box plots. Thank you. It's over, guys.
Thank you, sir. Any question, participants?
Thank you, sir.
Madam,
Yeah.
I have one question with sir.
Yeah, you can ask sir directly instead of going through madam.
Sir, these are the statistical methods, and how these statistical methods is with the real value.
Right, real value such as you collect a sample. In fact, I advise.
Suppose we are doing some experimental. So these are the theoretical value. How much difference between theoretical and experimental value?
You would not know. You would not know. You are only starting with the null hypothesis that there is no difference. You are not proposing certain value. You are simply saying no difference. Then you come up with some difference. Then you say, wow, it has some effect. This is the case.
Sir. Thank you, sir.
Yeah. Any other questions?
Sir, would you like to suggest some reference for this
Pardon me?
hypothesis? Sir, any reference for further study?
No, I would say this is the foundation. Whoever gives lectures on say t-test, chi-square test, and f-tests on those things, all kinds of tests, when they talk about those things like you reject the null hypothesis or p-value is this much, etc., then you quickly know, this is what he's talking about. Okay. So if this is my third lecture in a course, rest 25 lectures will depend on this concept. Okay.
Sir, please suggest us some book which has these introductory
Yes, sir.
chapters.
Reference book I am asking.
I see this is a very perennial question. There are no good books of this level There are some books written by some college teachers. They are, in my opinion, they're not up to the mark. They do not convey the essence, the excitement of doing stats.
So any book from you?
Uh, I am currently writing a book, which hopefully by next year it will be there. It was a great demand from my students who are now teachers in many zoology departments and botany departments in Delhi University. They have,
Yes, sir. Now we have another paper in third year, biostatistic. For
yeah,
that we need.
I know. And so they have been literally pestering me, sir, when are you going to finish it? When are you going to finish the book? I have completed almost about 70% of it. Hopefully, by the end of this year, it will see the light of the day. I don't know. We will see how. Yeah, definitely. And it will be ideal book, very informal style, hopefully. And let us see. You will know when it is published.
But sir,
Thank you
currently,
so
can
much.
we have any recommendations
Just
for
read any one of the standard. I don't know what is available to me. The problem is a lot of these books, standard books used in Western statistics courses, are available now as PDF versions, legal or illegal, whatever. You can download all of them, buy some books. I would say that there is one book that is available in Indian markets as an official Indian version edition, which is not too bad, maybe 500, 600 rupees. Czar's book on biostatistical analysis. Okay. It is too huge to sort of, maybe it might scare you. There are no simple ones for the undergraduate level. See, even for undergraduate level, there are some very good books. Western, I have 3 or 4, and of course, I have taken these courses in the US, so I have known how it is dealt with. But they do it very leisurely, covering one semester, sometimes 2 semesters. So things progress so slowly, nicely that each student gets to understand the concept very well with different examples. And another situation I have is that I do not wish to use real life examples. I quote real life parameters, real life variables, but I do not try to get some published values and all those things. This will require getting official permission to use those data and copyright laws and all those things. But for instance, if I am looking at normal distribution using heartbeat as a variable or a blood pressure parameters like systole as a parameter, I know the range in which it should lie. I can make up a sample values. I don't have to go to a hospital and say, give me your records. But they still understand. I asked students to generate their own data for any of these tests. Like for normal distribution, in my book, the book in progress is, I tell them, go and generate your own data. It's very simple. I look at a bunch of seeds available from some trees, weigh them in your lab. You have a sample. Meet a bunch of elderly people in a senior citizen home, ask them what are the blood pressure readings. You have a value, we have a sample that you could analyze. Get all the things like mean, standard deviation, standard error, kurtosis, skewness, everything. Then it is more exciting because you collected the data. You could go on. Suppose now you some research oriented, you are interested. Go to a senior citizen home, you record their blood pressure readings separately for men and women. Lo and behold, you have a t-test possibility of comparing females versus males blood pressure. Null hypothesis is no difference. So it all depends on the teacher. You should not teach a dry subject. You should encourage them and say, students, go collect some the observations and we'll analyze.
So how the biostatistic can be made easy for the students, because students are coming and they are saying, मैम हम तो बायो पढ़ने के लिए आए थे, आप हमें दोबारा से मैथ्स पढ़ा रहे हो, ये तो हम मतलब मुश्किल है हमारे लिए.
This has been a very problematic thing right from the beginning, almost 40 years ago, when I started teaching biostats to PhD students. Not even those days, maths it was unknown. It's the most People who have inhibition for maths or mathophobia, they would go into biology, not engineering. And so you end up with a bunch of students who are literally scared of maths. One of my friends used to say that these students are such that if you say let the sample size be 10, they feel comfortable. But if you say let the sample size be n, suddenly you घबराहट होती है. He used to say.
हाँ जी सर, और जैसे आपने बोला कि सैंपल कलेक्ट करने के लिए दे, तो सर अभी तो जीपीटी से वो चैट जीपीटी से वो करके ले आते हैं सारा प्रोजेक्ट.
Problem, you see, you can always cheat. You can generate data when the teacher asks generate your own data. Sit in, ask chat GPT. I want sort of readings for systole measurements for senior citizens. He'll spew out in just less than a second. Some originality is lost, creativity is lost. This is a problem. Even in the US now, at the time of graduation, and 2 or 3 guys showed the thesis and said, "Sir, this is not my original. I just did this whole thing with ChatGPT." Now, at that stage, where it is too late to simply say, "We cancel your degree." Okay, so this is a problem, So, your generation is facing this kind of a problem with ChatGPT. A lot of will face this problem. It's becoming very difficult to check if the student is as intelligent as his thesis indicates, because he might have simply got 95% help from ChatGPT. There's no way to check. So, most want to do oral testing, give paper on the spot and say read and interpret and things like that. So he won't have time to do chat GPT inquiry. I don't know. This is your generation that is going to face this big problem. I'm through with it. I'm fascinated by it, but I don't have to worry about this being misused in stats classes. But this is a genuine problem. As example, you yourself said, if you ask them to generate own data, they can come back. They have their laptop right then and there. They'll show you. They didn't do it. They simply asked Chat GPT guy, whoever it is, they generated the data. You didn't do it. A fully nicely designed biostat 1 hour of interaction with the students, where you go with the students into the field, the college campus, find out what kind of samples you can collect on what kinds of variables. You go to the cafeteria, you sit there and you can make so many behavioral observations. Right? The number of times a boy is staring at a girl, that's a quantifiable observation. Things like that, there are so many parameters. You can look at a tree and see the number of pods or fruits it has. And within the fruits, you can count the number of seeds. Is there a variability? It's endless, but the thing is, if you leave it to the students, why would they take the trouble? They would rather get Chat GPT's help. And many people simply, they say, it's just something that I have to take because it's mandatory. I take it. But later, for all my research on molecular biology, genetics, epigenetics, genomics, and all those things, if I need stats, I have my software. Very sophisticated. I press a key, I get all the standard deviations, etc. I press a key, it tells the level of significance, p-value. So you are, in the present generation, you are going through something that when you introduce biostats, I tell the students, all this year, you can be able to do it in about 10 minutes. But the reason you are here is you want to understand the basics, the concepts, the conceptual foundation. That you should learn. After that, what you do, I never expect my students who have taken these courses to go back and do all these manual calculations. They sit there and press one key from their software and get all the parameters to the 3rd decimal, 4th decimal. The reason I ask them to do these manual calculations is that they follow what's happening, not that they would use it. Okay. Well, enough sort of pravachan to the students. So
Thank you so much.
I wish you all the best. Okay.
Thank you.
Okay. So
So,
I was about to say see you next, but I will not be able to see you. So thanks to Sonika and the Daulat College organizers for giving me a chance to at least address 2 topics to you. It would have been 10 times more exciting and more fascinating and more rewarding had I been able to give this offline and looking at all of you. You are inquisitive.
Thank you. Thank you so
Thank you
much,
so
sir.
much, sir. Sir,
Okay.
so on the behalf of organizing committee, I would like to extend a heartfelt thank you to Professor T.R. Rao. Sir, even in the 5 minutes break जो आपने दिया था, participant were so excited and they were discussing and interacting with you. This shows you an engaging and insightful session. Sir, we hope to have you the pleasure to have you again in the future. Thank you so much, sir.
Thank you so much. I am honored, privileged to give a lecture here at Daulat College.
Thank you, Bhanu, sir.
Thank you and bye.
Bye, sir.
Okay. Bye.
So participants, we are running short of time. Next lecture will be just after this. And just one request that mute yourself in between the session. Please maintain the decorum and mute yourself. If you want to ask, then only unmute yourself. Thank you.
Hello, sir. Good morning.
Hello. Good afternoon. Can you hear me?
Yes, sir. We are able
Yes,
to
sir,
hear
we
you.
can hear you.
Okay, so let me just bring myself. If you are ready, we can start.
Yes, sir, we are ready. So we are already familiar with our speaker, Professor K.V. Bhanu Murthy. Sir has already graced us with the insightful and enriching sessions. We are truly honored to have you back, sir. And the topic for today's session is measure theory. Welcome, sir.
Yeah, I'll start straight away, I think, because it is a quite a lengthy and a detailed topic, and as I have already requested that it may be that I might have to overstep by 10-15 minutes. I hope that's okay.
Yes, sir, definitely.
First of all, I just want to make 2 clarifications. Yesterday, there was a question from, I think, I don't remember, it was some Kamal ma'am or someone. So, when I was speaking about data is something which has information and value. And I also said that data is not only numbers, it could be anything, it could be color, it could be, pictures, anything. Then there was a question, how can color have value? So I thought later that I think I should be clarifying this point. So I'll just take 1 minute to clarify it. when I say value, then it doesn't mean in money terms. Value doesn't mean price. Value means it holds some meaning. So, as I gave the example, in forensic science, suppose we are trying to identify some criminal and we have got other information, but suppose we add the information about the color of the skin or the type of hair, then it adds value in the sense that it allows better interpretation. It allows us to make some meaningful observation. So when I say value, don't think of it in terms of being something which has got monetary value. Value just means that it has meaning and it adds to our understanding. It adds to our description. It adds to our analysis. This is one point that I just want to clarify. Another thing is, this could be of interest since we're speaking about data. This could be of interest. So I just want to show you something if possible. Yeah. I'll just use the whiteboard for a few minutes. We, at the end of the lecture, we were talking about data generating process. This is another very important aspect of data because what happens is why is this not filling up? Yeah. What happens is that data is generated from nature. Say, for example, you are teachers from life sciences. Suppose I give the example of growth of bacteria. Okay, somehow the line is not coming straight. So growth of bacteria. So what do you expect? The growth of bacteria will take an exponential growth. So it will be growing at an exponential rate. So the data which is generated in nature is something which comes out of certain natural processes. So it could, suppose I'm talking about stock markets. I'm talking about stock markets. Now, so what is the information that was backing up this exponential kind of growth pattern? The information was that bacteria have a certain propensity to multiply. They multiply very fast. And so it leads to a pattern of data being generated, which is a exponential or a log function. If it is a stock market, in stock market, the information goes very randomly. Okay, you don't know why these peaks and troughs are taking place. So in a stock market, you can expect this kind of a pattern of data. Okay, so such a pattern of data is known as random walk data. So what I'm trying to say is this: in future, whenever you take up any research proposal, project, any research, any experiment, you should have an idea about what you can expect, what kind of pattern of data generation is likely to take place. That will help you in formulating your research problem and your research design. I hope what I have said holds some value to all of you. And it is a very complicated thing. I can't speak more than this. And now I will go on to my main topic for today. So this is now basics of measurement theory or measure theory. You could call it either measurement theory or measure theory. Okay, so so in research, basically I said two things. I said a scientist does the job of explaining the real world. And what does a researcher do? A researcher does something very similar, but still, when a scientist comes up with a theory to explain what is happening in the real world, maybe in biology, I said somebody is trying to explain the laws of plant physiology or of inheritance of characters and so on and so forth. So the scientists have come up with theories. But then those theories are not complete. There will always be a gap between what we find in the real world and what theory tells us. So the researcher's job is to bridge this gap. Okay? So both are trying to explain the real world. Okay? They are trying to explain either events or objects or phenomena that are taking place in the real world. Okay? A physicist will explain phenomena relating to magnetism, to light, to heat, and so on, to mechanics. Okay, a biology teacher will try to, or a researcher will try to explain something, as I said, about growth of bacteria or plants, or inherit or crossbreeding of plant varieties, all of this. So basically, both the scientist and the researcher are doing the same thing. They are looking into the real world, while the scientist looks into the real world and comes up with a theory. And we have already said what are the characteristics of theory. I'm not repeating that. But still, there is a gap which remains. That gap is something which the researcher tries to bridge, tries to cover. And as I said earlier, whatever I'm saying, it applies for empirical research, not for research like literature, arts, aesthetics, architecture, and so on. So in empirical research, we are studying, a researcher is studying the objects or events in the real world. The whole point about this measure theory is when we study objects or events or happenings or phenomena which are taking place in the real world, in empirical research, we need to measure them. So the measure theory, in short, is the theory which tells us about the process of measurement, the limitations of this kind of measurement, what kind of statistical tools can be used for analyzing these measures, what are the precautions you can say, or what are the properties of these measures. So all of this is measure theory. So there is an impression as though measure theory is meant only for social scientists, and I will come to that shortly, but it is equally applicable to all. It is applicable to social scientists, and natural scientists, physical scientists, and everybody, right from chemistry up to biochemistry or biophysics or anything. So since research is done into the real world, these events and objects, where do they exist? They exist in the real world. Now, in statistical inference theory, this real world is identified as the population. But when it comes to measure theory, we are looking at it as such. I will give two terms very shortly. Then you will understand that in measure theory, how do we look at real world? They could, I said, it could be objects or events. It could also be phenomena. For example, in economics, there is a phenomenon of poverty. In marketing, there is a phenomenon of brand loyalty. In finance, there is a phenomenon of efficiency. In sociology, there is a phenomenon of status of women. In HR, human resource management, there is a phenomenon of employee engagement. In political science, there is a phenomenon of power, of corruption. In psychology, there is a phenomenon of cognitive ability. So it depends upon your discipline. What is the phenomenon that you are looking at in the real world? And so on. I have given so many other, some examples I have said from life sciences and from physical sciences. The process of genetic inheritance of characters, exothermic reactions, shape of the universe. In astrophysics, we talk about the shape of the universe. And then in environmental chemistry, we would talk about SPM, that is suspended particulate matter. In physics, we'll talk about Bernoulli's principle or the buoyancy of a floating object. In mechanics or something, we will talk about the trajectory of a missile. So these are all phenomena. So measurement theory is a branch of applied mathematics. It is useful in the context of measuring events, objects, and phenomena. And therefore, it is an essential theory when we are indulging in empirical research and the data analysis which follows empirical research. Am I clear to everyone? Please say yes or no in the chat. Just put Y. If you are clear, put Y in the chat. Okay. Okay, so I'm proceeding now. What is measure theory? The fundamental idea of measurement theory or measure theory is a phenomenon is represented by its attributes, not by the phenomenon itself. So a scientist, for example, a physicist is trying to do some research about energy, or a physicist is doing some research about sonar waves, okay, sound, or about electromagnetism, okay. So these are all phenomena. Now, it is at one level, it's a very simple concept, but at another level, it is very complex. It requires a bit of imagination. So if a scientist is measuring energy or sound or light, is there a place where he can go and take a yardstick, take a tape and measure it? No. So what is the scientist measuring actually? The scientist is measuring an image of energy. The scientist is measuring an image of sound. The scientist is measuring an image of magnetism. There is no way in which you can actually physically measure them. So the scientists, the field of science has developed certain measures, and it is by certain attributes, okay, that you measure all these phenomena. So what you are measuring, this underlying phenomenon is being reflected in certain properties or attributes. So what you measure are those properties or those attributes. Now, for a particular phenomenon, there may be a number of attributes. All those attributes put together will give you a picture, okay, of the phenomenon that you are trying to measure. That itself is not the phenomenon of energy, power, science, electricity, or something. You know, so what we must realize is that measure theory is so fundamental that it is telling us that yes, you are researching about something which is happening in the real world, whether as a life scientist or as a physical scientist or as a social scientist. But what you are measuring are the attributes of that phenomenon, of that event, of that object. Okay? You are not actually measuring the thing itself. Therefore, there is a problem. What is the problem? There is a problem of imprecision, because that means you are using some man-made tools for measuring something in the real world, measuring something in the real. So these tools that we are using are likely to be imprecise. So if different people in different contexts are using these tools, there is a need that all of them are doing it in the same way, in the right way, and in a way which is standardized. So therefore, measure theory is telling us, number one, you are not actually measuring what is underlying in the real world. You are measuring an image of it. You are measuring it with the help of certain attributes. And then whatever tools by which you are measuring it are not something which are absolute or perfect. There would be imprecision in it, and therefore we need a theory which explains to us how all this process of measurement needs to be dealt with, needs to be understood, needs to be theorized. There has to be a theory which is common for all branches. And therefore, the thing which deals with this is a branch of mathematics, and also it involves some amount of statistics, okay, for understanding how do we assign some numerical values to characteristics of objects. I just now said that when we were talking about color of the hair, color of the skin, I said it has value, and we have to assign some numerical values of those characteristics of objects. What are the objects? The objects over here are color of the skin, color of the hair, and so on. Okay. The phenomena and what is happening, the processes, all of this has to be done in a systematic way with a sound theoretical basis. It provides a framework to ensure that measurements are, now, what is the purpose or what are the objectives of this theory? That the measurements that you do, they should be valid, they should be reliable, and they should be meaningful. So there are three basic ideas behind measure theory, that you are measuring something which is not actually the thing which is there in the real world, but you're measuring an image of it. And you're measuring an image of it by measuring certain characteristics or certain attributes. You are using some tools or measures to measure it. But all of this has to be done in such a way that your measures are valid, reliable, and meaningful. I will come to this in a little while and explain these three terms: what is valid, what is reliable, and what is meaningful. Okay, let me come out with it. Validity is that, so let me take an example, because otherwise you will not be able to follow. Validity is about I'm taking an example from social sciences. Suppose I'm doing I think all of you understand what is, yesterday we talked about primary survey, primary data, and so on. So how is primary data collected? It is collected through a questionnaire. So I'm a social scientist, I'm an economist, or I'm a management person. I design a questionnaire and I give it to 100 respondents. There are questions in that. Now, if my questions are not well designed, then the respondents, okay, those people who are responding to my questionnaire, they are likely, if they don't understand what I'm asking them, then they may be giving some answers which are not relevant. Okay. So, for example, I ask somebody that, are you happy? Okay. And he says, I'm married. Okay. I mean, just to put it in a funny way, right? So, validity is is your instrument by which you are trying to measure some responses, is that being presented in such a way that the person who is supposed to give the answer is understanding exactly what you want him or her to speak about. I'm not saying that we dictate a certain answer. All that we are saying is that if we have an intention of a certain question, then the respondent should understand what exactly we are asking. If that is not clear, then your instrument of measurement is not valid. Now, what is reliable? Reliability means that the same questionnaire, you give it to 100 people, and if they don't care and they just go on ticking some option, everybody puts out of 1 to 5, everybody puts 3. That means it is not reliable because they are not caring enough to give the right answers. Their responses are not going to lead to reliable or good information. And then thirdly, after all of this, if your questionnaire has not been well designed, then you may not be getting any concrete meaning out of it. So all of this refers to, so in social sciences, what is known as the measurement technique or tool is the questionnaire. And the questionnaire is also known as the instrument. So if there are any social scientists, we refer to the questionnaire as the instrument. Now, the similar thing in sciences is the physical instruments that you have. Okay, you measure temperature, you measure pressure, you measure altitude, and you measure so many things. Okay, humidity or whatever. So the point is, with all of these instruments, you are measuring certain attributes. So all these 3 criteria, validity, reliability, and meaningfulness, all of them even apply to the physical instruments that are being used by scientists. Okay. So what does measure theory address? What are the principles that measure theory addresses? Defining and quantifying attributes. So first of all, when we talk about measure theory, we should be defining and quantifying attributes. I have said it earlier, we are not measuring the actual phenomenon, we are measuring certain attributes. It helps to identify and define what exactly is being measured. So first of all, you must be clear what exactly are you measuring. Okay. And then how to assign numbers to what is being measured. And that those numbers should be such that they are able to give you some meaningful measure of the underlying attribute. Okay. Second thing is this, I said it when I was talking about data, that data is not numbers. A data can be, of any meaning or any use, or as I said, any value, only if it is put in a scale. So the second thing is that measure theory categorizes measurements into different scales. These are some of the scales, you might have heard about them. Somebody was talking about cardinal value yesterday. So nominal, ordinal, interval, ratio, all of these are scales of measurement. And what happens is that in different circumstances, you are supposed to identify and use and specify one or more of these scales, and each of these scales has got certain unique statistical properties. Okay, this is where, although measure theory is a theory of applied mathematics, but it also verges on statistics at some level. Precision and accuracy. It emphasizes the importance of minimizing error. Okay, so there will always be human error when we use some of these instruments, and ensuring that measurements are both precise. What does precise mean? It is repeatable, that every time that you do use the tool, you use the measure, you get the same kind of result. It doesn't keep varying. Okay, and accuracy. So there are two parts to, there is precision and there is accuracy. Though they mean different things. Precision means that the tool is precise in the sense that you can keep repeating the use of the tool, but it will return the same kind of result. And accuracy means that every time that you use the tool, it gives us a measure which is close to the true value. Now, true value is something which is lying in the underlying real world, but what we are measuring, as I said, is an image of it. So it should be accurate so that this measure comes close to the true value. Okay. So can I proceed? I have to go a bit fast. There is a lot we have to do.
Yes, sir.
Okay. Then we have validation and reliability. I have just told you a little bit here that validity and reliability. It also guides methods for ensuring that the tools and processes used for measurement are consistent and they produce both valid. What is valid? I said measuring what is intended to measure. So your instruments, you think of it in your own context. Okay, suppose you use an amp meter or voltmeter or use some other instrument. The validity would mean that is it designed to measure what you intend to measure? That is validity. And the second thing is reliability. That means that the results which are coming are under trustworthy conditions. So I'll give you an example. For example, when you do a survey, there are people who are known as investigators. They go to a village and they are supposed to go from door to door and collect data. Now, suppose some of those investigators, they say, who is looking at us? Why should I spend so much time? I'll go and sit below the tree in the village and I'll fill in whatever numbers I want to fill in. What does that lead to? It leads to unreliable data. Similarly, you give a questionnaire to some young students, they are more bothered about going out for a movie. They'll say, let us tick any option in this. How does it matter? So these kinds of, problems, they lead to unreliable data. And suppose your question itself is ill-designed, and then people don't understand what you're asking, then their responses are likely to be imprecise or wrong. So this is validation and reliability. In practical application, measurement theory is used across different fields: environmental science, educational assessment, management systems, even quantum mechanics. There is a whole area of study of how to apply measure theory in quantum mechanics. I don't have either the capability or the time to explain, but if any of you are interested, please go and read, and you will find out that even in such a topic like quantum mechanics, there also measure theory plays a role. It ensures that the data collected is trustworthy, enabling you to make informed what did we say about data? We said data has information, it has value, and therefore it has meaning. Any researcher is doing research, please mark my words, to create new meaning. So the most important thing is that whatever processes you use, they have to result in meaningful results. It should make some sense. You should be coming up with something new. That can happen only if your processes result in something meaningful. Okay? So therefore, all of this is as much applicable to sciences, life sciences, physical sciences. Of course, social sciences were kept in mind originally when we were talking about. So now I'm repeating one thing very quickly, that there are two theories. One theory is statistical inference theory. So in statistical inference theory, please note, we are studying the relationship between the sample and the population. Statistical inference theory is about the relationship between the sample and the population. Okay? And out of this comes a very important part, which is hypothesis testing. I would like to point out that in sciences, this hypothesis testing thing is not so very well, handled. Okay, it is more awareness about testing of hypothesis is there. Of course, I'm not saying it is not there, but it is better handled amongst social scientists. Anyway, the point is, classical inference theory is about the relationship between the sample and the population. Now, here, what are all there in classical inference theory? We study what is known as sampling frame, sampling method, sample size, and testing of hypothesis. Most of these things you people might have heard, or you will come across in another lecture, even in this refresher course. But I'm explaining one thing which many people don't talk about. I think this is important, you should know. It is not directly related to my lecture. What is sampling frame? Has anybody heard about sampling frame?
Is it the number of, sir, like the number of, say, population we are taking into the account of during sampling? Or the limit of, say, an age group we are...
No.
Okay.
Today's newspaper, there's a very nice report. There is something called a bird atlas for Delhi. Have you seen in today's newspaper? And they have identified that in this summer, 160 bird species have been found in Delhi. And this is a voluntary effort. So now, suppose I want to know, how did you arrive at this number, 160? That there are 160 species in this summer in Delhi.
That
Then,
means the observers, the people who are being observing might be that it means the people who are trying to take these observations might be listing all birds and then their focus is on this sample.
No. See, what you're not understanding, sampling frame is about where are you going to find your respondents? Where are you going to find your individuals? So suppose I'm doing a survey on birds. Where am I going to look for them? Suppose I'm doing a research on stock market investors, okay? And I want to collect data on a sample of stock market investors. The question will come, where are you going to look for these investors? Do you understand my language?
Yes, sir. Maybe, yeah. Some stock exchange.
What is the source? Where are you going to find these individuals? Okay, so in the in the context of bird atlas, someone has to decide that if I have to find out how many species of birds are there, what are those places where I have to go and see? And that has to be listed out. That we looked at these locations. We looked at Okhla Barrage. We looked at Sultanpur Bird Sanctuary. We looked at IP College. IP College has done a similar census. And so these are the places. So where do you find your sample? That is sampling frame. Okay. I just mentioned this because most people are not very aware of what is sampling frame. Okay. So statistical inference theory interprets, analyzes data, and makes generalizations or predictions about the population. Measure theory ensures that the quality and integrity of data is good. Okay. In a sense, measure theory is about obtaining accurate and meaningful data, while statistical inference theory is about what do you do with that data, how do you use that data later on for finding out what is happening in the population. So, in a sense, measure theory should come before statistical inference theory. If you don't have good quality data, then your whatever results and tools that you use in statistical inference theory, we are not likely to give you the right answers. Is it clear? So, measure theory, hence, if you can draw conclusions about the attributes, you must take into account the nature of correspondence. So now I'm coming to something which is a bit more complex. So let us agree, as we have said earlier, we have said that any scientist is not actually measuring what is happening in the real world. They are measuring something, they are measuring some attributes. Okay. So measure theory teaches us about the conceptual framework, including the assumptions that are required for using certain measurements and how these statistics are derived. What kind of statistics are derivable, not derived, are derivable from which kind of measures. So there are certain kinds of measures can give you certain kinds of statistics. Okay, certain kinds of measures cannot give you certain kinds of statistics. And also that whatever data that you have gathered, it should be meaningful. It should not just be random data. Okay. It should be precise. It should be reliable. Okay. Information about reality and also the underlying assumptions and concepts. Now, this is what we have to see. How does measure theory apply to physical sciences? This is of importance to you people. Measurement theory plays a foundational role in physical sciences. It ensures precision, consistency, reliability in experiments and observation. And why is it important? One, defining physical quantities. First and foremost contribution of measure theory is defining quantities. Before you go ahead with your experiment, first and foremost, you have to define what are the quantities. Okay. The second thing is, because I said any data, any quantity has to be set in a scale. So you have to understand what is the way in which you have standardized the measures. Okay, what is the scale? And you have to, for each of the words, which are each of the things that I'm using here, not only that you have to ensure this, you have to give a justification for your choice. If you are defining certain physical quantities, there has to be a justification for defining them. The justification can come from literature, or the justification could come from your own approach if you are using some new definition. Okay. Accuracy in experiments. Accuracy, as we said, is different from definition, standardization, accuracy. Accuracy, it involves minimizing the errors and the uncertainties. When a scientist looks at the outcomes and the data from your experiment, he or she would get the doubt that, can I rely on this data? Okay. So your job as a scientist is to minimize the error and remove the uncertainty for any experiment, or in future if someone else is using that data. So in that context also. So for example, I'm just giving one example which I have found. In quantum physics, even a minute variation in measurement can lead to vastly different conclusions. I don't know much about quantum physics, but I have just found this. So you have to define the physical quantities, you have to define the process or the scale and the standardization. You must ensure that accuracy is there in the experiments. Precision in, I gave you earlier the difference between accuracy and precision. Okay, I'm not repeating over here. So both aspects are there, accuracy and precision. Precision means that you are going as close as possible to the underlying real world phenomena or object or event that you're measuring. Validation of theories. Another aspect is that measure theory is also about validation of theories. Okay. Physical theories like Newton's laws, quantum mechanics rely on precise measurements for their validation. So if your measure itself is not reliable, then the process of validation can be faulty. Repeatability. So if you have done an experiment and if you ensure all of what we have said so far, then there is a reasonable chance that anyone who uses your tools, your measures, and your method can easily repeat it in a different context and it would give consistent results. So repeatability, this is another part of measure theory. So these are all the aspects we said. So 6 things have to be kept in mind: defining the physical quantities, defining the standard, accuracy in the experiments, precision in experiments, validation, and repeatability. Now we come to the most complex part of this. Just give me a second. I hope what I'm saying is clear and my rate at which I'm speaking is okay. Is it okay?
Yes.
Now,
Yes, sir.
concentrate on this diagram. It is not easy. Okay. So I start by saying, so far we have understood one thing, that data, there is a data generating process. That data generating process happens in the real world. I gave you examples how the real world has got the propensity to generate data. I gave the examples of population growth, of growth of bacteria, and so on and so forth. So all of this, where is it happening? It is happening in the real world and it results in the generation of data. This whole space, you can call it a set, as you can see. This is like a Venn diagram. Okay. This whole space, we call it the empirical space. The empirical space is where in the real world these happenings are taking place, this data is being generated. Okay. But as I said earlier, you don't actually measure in the real world. What you measure are certain attributes. And the sum total of these attributes, it results in a construct. What is a construct? The other word for a construct is an image. So I am not measuring physically what is actually there in the underlying real world, and the real world is giving me some kind of feedback in the form of certain data which is being generated. I am using certain measures and applying them on the different attributes of the phenomena. Okay. And the sum total of all those attributes, that creates an image. Now look at this equation at the bottom. A construct is Y. Okay. It is an image. It is an image of what? It is an image of an event or an object or a phenomenon which is taking place in the real world. And those phenomena, those events, they generate certain parameters, you can say, okay, data. And those datas, that data is captured with the help of certain attributes. And all of those attributes put together, when you put everything together, again, I go back to my forensic science, okay? What are the attributes? Color of the skin, color of the hair, height of the person, okay? Color of the eyes, and ethnicity. All of these are attributes, okay? So all of this put together, now धीरे धीरे जब हम ये सारे एट्रीब्यूट्स को मेजर करते जाते हैं, then a picture emerges. So what you are measuring is a picture, it's an image. So we are dealing with two spaces. One is an empirical space and one is an image space. The empirical space belongs to the real world and the image space belongs to the world of research, the world of research design, of what we are doing, all of what we are doing. So we are operating in this space, but we are drawing conclusions about this space, about, let me use my pointer. So we are operating in this space. Sorry. We are operating in this space, okay, by measuring certain attributes. The sum total of these attributes leads to a construct, this yellow thing, okay. I said, what is a function? In a function, you input certain values and you get an output. So you are inputting all the values of the data from these attributes into the function, and then what are you getting out of it? You are getting an image out of it. And this is what you are measuring. Okay. So basically the researcher, there is a dividing line over here. The researcher is in this space, in the image, operates in the image space. But the purpose of the researcher is to understand this space, which is your real world, which is reflected through certain data generating processes in the empirical space. I want a clear yes or no if you have understood this or not. This is the most crucial part of whatever I've done in yesterday's lecture and in today's lecture. Please let me have an answer. Are you clear about what I'm saying?
Yes, sir.
Yes or no?
Yes, sir.
Okay. Can I proceed?
Sure, sir.
Okay. So, measurement of constructs. So your job as a scientist, social scientist, is to think up of a construct. When you start your research, you should be aware that I am not actually measuring the real world. I am measuring certain attributes, and you have to build up an image, a construct. Okay. So measurement of constructs. right? So the theoretical propositions consist of relationship between abstract constructs. Testing theories, theoretical propositions, requires measurement of these constructs accurately, correctly, in a scientific manner before the strength of their relationships can be tested. What did we see over here? We saw that we are trying to build up a relationship between this X and Y. Okay? Data is being generated here, and we are deriving something from the image over here. Okay? And because the entire space is not measured, then we are using small x and small y. Okay, somewhere a little bit of sample comes here, but in this image space, let me put it this way. In this image space, if 5 different scientists are using different attributes and different measures, then you could have different sets over here. There will be one yellow set, there may be a blue set, there may be an orange set over here, or there could be a violet set or a pink set. So that depends upon the specifics of your own research design and the attributes and the measures that you're using. So there could be a lot of variation. But whatever you do, it has to follow the principles of measure theory. So, so basically, measurement refers to careful, deliberate observations of the real world and is the essence of empirical research. While some constructs in social science research, such as person's age, weight, or firm size, it may be easy to measure. But there are other constructs. Say, for example, in social sciences, suppose I'm measuring creativity. I'm measuring application of mind. Okay? I'm measuring the ability to adjust. I'm measuring the status of women, okay, in society. Now, these are all things which are very difficult to measure. And therefore, I need to have a theory which tells me how best I can do it. Okay. So the first part, as I said, is conceptualization. Conceptualization refers to the building up of this image. Conceptualization is a mental process by which fuzzy and imprecise concepts can be clarified and you can make them concrete, and you have to put them down in writing and make it clear in precise terms. For example, you can use a Venn diagram, you could use a flow chart, you could use some of these. These days there are more complex. There are mapping, maps and so on and so forth. There are techniques by which you can do it. So this would be the first step. Okay. Let us say that I want to measure poverty. Now I can't go out in the market and say, okay, where is poverty? Let me measure it. So we have to measure an image of poverty. Okay. But then how do we measure the attributes which lead to poverty? Okay. How much calorific intake am I having? Do I have good transport facilities? Do I have some kind of social, status? All these things need to be put together to define poverty. Okay. The process of understanding what needs to be included and what needs to be excluded. So this whole conceptualization stage, you have to think what all needs to be included, what needs to be excluded. Okay. Similarly, for other measures, other concepts like efficiency and so on. Once a theoretical construct is defined, okay, you have defined your image, okay, then you think of how exactly you have to measure it. This process is known as operationalization. You convert it into practical ways by identifying what are the indicators or what are the items, okay, for measuring this image. Okay. For instance, suppose an unobservable theoretical construct. I think most of you are from Daulat College. I don't know, you may be having gentlemen there also, but I'm assuming many of the participants may be women. So you should understand. Suppose I say my construct is, my research problem is to measure the status of women. Okay. So now I have to first I'd make a construct, an image. Then I have to operationalize it by identifying the indicators. Okay. For example, now I think about it. How does the husband treat the woman? Who takes decisions? How are the relations within the family? How do in-laws treat her? How much power does she have? So on and so forth. So there is a subjectivity about all of these things. It will be bound to be not so precise, and there will be very complex relationships between these different aspects as well. Okay, so some of the demographics things like age, gender, education, they are simple and you can use some very clear-cut measures for it. The whole process allows us to examine the closeness amongst these indicators as an assessment of the accuracy. So the better you design the image and the better you are able to identify the indicators or the items and then define what should be the precise measures, the closer are you coming to the reality. So because we said precision means you should be coming closer to the reality. So an object or an event can be described and categorized in multiple ways. Each description is an attribute. Okay, like I just said over here. So the measurement of a specific numeric attribute carries a specific number of units. Now here I said, if you look back at all the steps, this is one step where you are doing the standardization. Okay. Then now the measurement processes identify the research problem, identify the attributes to be measured, choose the appropriate to be to measure the attributes, select the appropriate measurement tools. Okay. Estimate the specific measures. Now this is here, it is a matter of choice and defining. Here you are estimating using the specific measures to solve the problem. So this is a kind of a rubric for you to understand how we use measure theory. Okay. Now I think I'll have to go a bit faster. Measure theory encourages people to think about the meaning of their data. Okay. It encourages critical assumptions behind the analysis. It encourages responsible real-world data analysis. Some of these things, as you start, each and every word has importance, but I don't have the time. So you have to go over this and look at it in your own context. So now I'm saying that mathematical statistics concerns, that means your inference theory, it concerns the connect between your sample and population. Measure theory concerns the connect between data and reality. How representative is your data of the underlying reality? Because data is something which is helping you to build up an image of the reality. So measure theory is very important because this tells you how good, how qualitative, how good the your data is, how precise it is, how accurate it is, how good your measures are about data, and how representative are your measures of data of the underlying reality. So both statistical theory and measure theory, both are necessary to make inferences about the real world. What is the job that the scientist or the researcher does is to make inferences about the underlying real world. Okay. Definition of instruments. Why should we measure? Types of measuring, scales and the corresponding statistical measures. I said certain scales can be. Hello, somebody's audio is on. So first of all, definition of measurement. Measurement is used for acquiring information about certain objects, states, or phenomena. Hence, measurement must be descriptive. So, what are the characteristics of measurement? Descriptiveness. That means your measure should be able to explain things. So, descriptiveness is one of the characteristics of measurement. Selectivity. This is another characteristic of measurement. Selectivity, it may only provide information about what we wish to measure. So it should, see, these are two opposite views. Descriptive means it should be able to explain. But at the same time, selectivity means it should not be explaining everything. Then how do we know? We should know precisely about what we are interested in. So what we are going to measure. So both things are important. That if it doesn't explain anything, even then the measure is not right. If it explains too much and doesn't focus on what we want to know, even then the measure is not right. So it has to be something which describes, but at the same time, it is selective. It describes what we are intending to understand. Okay. Then objectivity. So my measure should be such that it doesn't depend upon my subjective wish and will and so on. It should be objective. So what are the characteristics? The characteristics are descriptiveness, selectivity, objectivity. Now, with the help of these properties, what we are doing is that there is an empirical space. Okay, we have seen this earlier. There is an empirical space. Out of this, there is a source set. This is a source set. This is from where you're drawing your observations. Okay, and this source set, with the help of certain attributes, you are creating an image set. If you will see over here that these are represented in small letters, which means these are samples. One person may have a different source set, someone else may have a third source set, and someone again may have correspondingly a different image set, and so on. Okay, so this leads to all these properties that we have talked about. Doesn't mean that there is only one unique image. It depends upon what you have chosen out of this, and that will lead to different image spaces. Okay. Now there is a phenomenon which we must understand. The source set and image set are said to be isomorphic. If the transformation does copy the source set structure, this is a very complicated answer rule, but please try to understand it. What I'm saying is different scientists may be picking up different source sets from here, and they may be resulting in different image sets over here. I, J, K, L, M. Okay. So there are different S, I, S, J, S, K, S, L. Okay. Here you have I, J, I, K, I, L. Okay. Different scientists have generated these different image sets. Now, if there is a property of isomorphism, then what it means is that whichever source set you pick up, okay, your measures should be such that they copy the structure in the underlying elements within your empirical space. So there are many things which happen. Everything is not singular. What happens in the real world is very complex. It consists of many things which are interacting. There is a structure by which they interact. All that structure, it will determine what your image is going to look like. So, if different scientists pick up different source sets and use certain attributes and measures, and it results in different images, provided that each of these images are still retaining the underlying structure, which is the relationship between different elements, it means that this is a proper representation of the empirical space. So it isn't as though that you can't have different instruments. It isn't as though that you can't choose different attributes. But provided that you do all this and different scientists do it in different ways, but if I'm using a word, I hope you'll understand this word. If the veracity, do you understand the word veracity? Please, I want an answer. If the veracity of the process of transforming the empirical space into an image space is retained, whatever kind of source set you choose, and if it results in different image spaces, this property is known as isomorphism. I'm sure in sciences you use isomorphism. Can somebody tell me any example of isomorphism in science? Isomorphism is same characteristics or similar characteristics. Hello?
Yes, sir.
Can somebody give me an example of isomorphism in any scientific phenomenon? Very quickly. Or if you're not able to, please assure me that this is the most complicated slide. Have you understood? Please say yes or no.
Sir, it is, I am not able to recall an example, but yes, in set theory, we have, for example, if we take the empirical set as 1, 2, 3, 4, and we multiply each number by 2. So we will be generating a set of even number which has a dependence y is equal to 2 times x.
No, you're looking at it in a mathematical way. I'm only trying to say, suppose there are 3 different scientists. One has chosen Si as the source set. You have chosen Sk as the source set, and another has chosen Sj as the source set. Is it okay? And then you use certain measures and use certain attributes, and then you generate out of that. From Si you generate Ii, from Sk you generate Ik, from Sj you generate Ij. 3 different images. Okay? But if these transformations from the empirical space to the image space, if they result in an image space which is a true representation of the empirical space, it is a true representation if it retains all the complexity of the underlying empirical space. Do you understand what I'm saying? The relationships amongst different attributes, the relationships amongst different variables, and all of that. elements. Is it okay? You are looking at it in a very simple mathematical form. I am saying that the empirical space is an organic space. There are many things happening there. There are many elements that are forming the empirical space. And those elements which are there in the empirical space have got different relationships amongst themselves. And that affects your phenomenon which you are studying. I am studying electromagnetism, I am studying light, I am studying energy, I am studying plant physiology. That is being affected by the relationships and the structure between all the elements which are there in the empirical space. Please say yes or no. Yes or no?
Sir, actually,
Yes, sir. Yes.
I am confused at one point. SI
Yes.
leads to II, SJ leads to IJ,
Yeah.
and so on. That is understandable.
Yes.
But these cannot be independent. II, IJ, and IK should have some kind of similar, what should I say? Similar.
One doesn't depend on the other. I am saying that the representativeness of the image space, because the image space is trying to do, can I use one word? Emulate. Do you understand the word emulate?
Yes, sir.
So the image space is emulating the empirical space. But different scientists are not likely to use exactly the same source set. You are likely to use different source sets. And there are different elements within the empirical space which have got a certain set of relationships that forms the structure of how the things in reality are related to each other, provided that your measurement process, it doesn't disturb that underlying structure, the underlying relationship. Okay, as long as ensured, then each transformation is isomorphic because it is not changing the underlying structure. So if it were to change, then it means that there is some problem with your measure. Do you understand my language?
Yes.
Okay. So I'm short of time. There's a lot I have to do. I have to take another 15-20 minutes at least.
Sir, is it like the isomorphic form of protein? Like, if we talk about isomorphism, so you want to say that isomorphic forms of protein like works that
Okay.
So is it like this that you are talking about?
Yeah, suppose you say that there are different chains of amino acids. That's what protein is.
Yes, yes.
Okay. So now these different chains of amino acids will lead to certain types of protein. Okay. And you want to study some properties of protein. Okay. But it isn't, there is nothing in nature where different scientists could not be picking up different samples. Okay. And different, I won't say samples, but the source set. And then they're analyzing them. Now, they could come to different conclusions. That is not a problem. But the point is this, that the measures that they use should not be bringing out anomalies and differences. Understood?
Yes, fine.
So this is about measure theory. Are you using the right process and measures which is not causing a bias in the process of transforming empirical space into image space? Is it clear?
Yes, sir, fine.
Okay. So in measure theory, the concept of isomorphic refers to a structural equivalence between measured spaces. If two measured spaces are said to be isomorphic, if there exists a measurable mapping between that preserves the measure theoretic properties. So the measure itself is not responsible for, this is a good word, it is not distorting. It is not distorting the image of how the image is reflecting the underlying empirical space. उसको वो बिगाड़ नहीं रहा है आपका measure. Please say yes or no. Yes or no?
Yes, yes, sir.
Yes, sir.
Okay. So now, so it's very important for all sciences, but for behavioral sciences. So you can, now the question is this, then now coming back to, so therefore, all of this means that there should be a scientific way in which the measurement process is developed. So when I say I'm developing a scale, okay, a part of your experiment is to develop a scale by which a measure, a scale, an instrument by which you are trying to attain this process of transformation. So you are supposed to, this is what measure theory is meant for. You have to develop a scale. Okay, that scale should have all those properties, should go through all those steps that we have talked of, that we have already spoken of. I'm not repeating. As a result of that, if I am able to develop a scale which is not resulting in any distortion, then that means there could be as many scales as possible. I create my own scale, you create your own scale, she creates her own scale. But all those scales must be ensuring that they're not distorting what is happening in the empirical space. Is this sentence clear?
Yes, sir.
Yes, sir.
Yes? Okay. So now the problem is there are some people who have worked on these scales and they have ensured that their scales are near to perfection. There are methods by which you can ensure that your scale is near to perfection, that it is not causing any distortion. Okay? So there are two options. Every scientist should look in literature to see, is there any standard scale which has already been developed, like you just said just now, that you are trying to study, let us say, the properties of आजकल एडवर्टाइजमेंट आता है ना अबाउट काउज मिल्क, सुना है आपने? काउज मिल्क. ओके, इन दैट दे से इट हैज गॉट अ लीनर प्रोटीन स्ट्रक्चर, सो इट इज गुड फॉर चिल्ड्रन. ये सुना है ना ऐड आपने?
Yes, sir. Yes, sir.
हाँ.
Yes.
So that is what I'm saying. So you're trying to develop some conclusions about, different proteins. Okay. So that is your research problem. So you have drawn out from different scientists have drawn out from empirical space, as I said, SI, SJ, SK, and they have drawn out II, IJ, IK. But provided that they have used the transformation process which depends upon the measurement process, and it is such that it results in isomorphism. There could be, these different approaches, there could be these different experiments looking into the same problem. Okay. So now here you have a choice. Either you look into literature and say, has somebody worked on this problem earlier? Has that person developed a scale which has pre-tested? Has that person ensured that all the required properties of the scale have been taken care of? Have they done some experiments in trying to perfect the scale? If you have such a pre-tested scale, then your first choice is that that pre-tested scale is likely to be isomorphic. It doesn't matter कि उसने डेटा कहीं यूएस से लिया है, आप डेटा अफ्रीका से ले रहे हो या कहीं से भी ले रहे हो. Are you understanding? But suppose you don't have a pre-tested scale, then you have a problem. Then you have to develop your own scale, and when you develop your own scale, you have to ensure all what I have been saying in the past half an hour. उसके अंदर accuracy होना चाहिए, वे होना चाहिए, all those steps, the process has to be followed, all the steps have to be ensured, all the properties, all of that has to be ensured. Have you understood now what is the purpose of measure theory?
Yes, sir.
Okay. So basically the outcome of measure theory is that there should be no loss of information. Isomorphism, what does it do? It does not lead to any loss of information. It retains the information. It retains the relationships. It retains what is happening in the underlying real world. How do different elements in the real world, what is the structure? What is their relationship? All of that which we want to investigate, all of that is not disturbed, provided that your measure is not causing any distortion. So measure theory is the process or the theory by which you create measures which do not cause distortion. Do you understand my language? Yes or no?
Yes, sir.
So therefore, sometimes what happens is that you have to create certain artifacts. What is artifact? Artifact is a contradiction in terms, because RT means artificial and fact means real. So what is an artifact? Artifact is what I've been referring to recently. I said it is an image. So image is not, obviously it is not real. But what is it referring to? What is the image referring to? It is referring to reality, na? You are making an image about reality. Okay? And how are you doing that? You are doing that through a process where you are creating an instrument, you are creating a questionnaire. The task of these instruments is to convert the state or phenomenon into different state or phenomenon in such a way that they are not misinterpreted, in such a way that they give the same meaning or similar meaning. Okay? So basically these are the process of developing the instrument should ensure that there is descriptiveness, selectivity, and objectivity. Okay? And so in pure sciences, the sole purpose is mostly describing the real world. So in pure sciences, therefore, we can form a better and more coherent and objective picture of the real world based on the information. It has an advantage because you're dealing with something which is concrete. Okay? So basically, you're able to have more precise and accurate measurement systems. Okay? In social sciences, the problem is that you are dealing with things which are not so concrete. It's not easy for us to develop this. Now, how do you know that the instrument that you have created, it is going in the right direction? For this, you have what is known as a pilot survey. Okay? Pilot survey, there is an example given here. In a pilot survey, what is a pilot survey? I created an instrument. For example, in social sciences, I created a questionnaire. I apply that questionnaire to 30 people or 40 people. If I find that I have a doubt that my questionnaire is actually creating a distortion, then I will try to alter that questionnaire and reframe it again, and then arrive at a final questionnaire. So this process is the testing process, the pilot survey. Similarly, in sciences, if you have developed some instruments and you have some preliminary results, then you should do a pilot kind of a study. Suppose you're doing something about productivity of certain rice variety or something like that. So you do it on a small scale and then see whether it is going in the right direction or not, or make the necessary changes. Now, this is a bit complicated. I'm just going over it very quickly. Because we are not going into hypothesis and also I'm not much of this. Now I'm coming to, I'll spend another 10, 12 minutes maybe. This is the practical part of what all we have been saying. I said that you create scales. What are the scales? The types of scales are nominal and ordinal, and then you have discrete and continuous. These are different qualitative scales are nominal and ordinal, and then numeric scales which are discrete and continuous. I think I'll have to skip this. This is it'll take a long time. So I'm just showing you through this diagram. These are all the scales: nominal, ordinal, interval, ratio, and absolute. This is something which is of practical use. These are the different scales. Now, there are examples over here which you can understand. A nominal scale, as the name suggests, nominal means which doesn't have a particular value. Okay. So, basically, it only goes as a this thing as 0 and 1. So yes, no, male, female, present, absent. So wherever you have to get this kind of information, then you will use a nominal scale. In this,
Sir, excuse me, sir, do we use the term Boolean in measurement theory? For
yes,
example,
you are right.
we use the
nominal
Boolean
scale is a Boolean scale.
Okay, sir. Is it okay to use this term here also?
No, it is not used in measure theory.
Okay,
But for us to understand, nominal scale is a Boolean scale.
Okay, sir.
And then ordinal scale where you are ranking things. Okay. Then you have interval scale where you have precise measures on a, basically you can look at interval scale in terms of the number line. The number line is there for minus infinity to plus infinity. Okay. And then even between one number and the other, let us say between 23 and 24, as the theory says, mathematics says, there are infinite numbers. Okay. So interval scale refers to that, where there is a continuous scale like your number line. Okay. So ratio scale refers to things like age or weight and so on. Now here, this is ratio scale. The property is that there is an absolute zero in this. Okay. In the case of the number line, it is not. And another thing is, in the case of ratio scale, if I have two numbers, suppose I say my weight is 70 or 80 kg and my son's weight is 40 kg. So I can say that I weigh twice the weight of my son. Okay. Or if I say age, I am 73 years old actually. Okay. Or 70 years old. And my son is 35 years old. So I can make a ratio between them. So all of this is possible only if your scale starts from absolute zero. So that is the ratio scale. Wherever you have a condition where there is an absolute zero, for example, suppose I talk about productivity of different varieties of wheat. Okay. So your absolute zero is zero productivity, which is not actually there, but nevertheless, for a scale, for comparison purposes, then I can say that one wheat variety is producing 1.2 whatever kg per, I don't know, square yard or something like that. Then absolute scale, this is used for weights, temperature, density, and so on. This is often used in sciences. One second. So I'm running short of time, but I want to tell certain things. In nominal scale, that, say, for example, if we are talking about roll numbers, a roll number, you have roll number 100 and you have roll number 110. Okay. Now, in any nominal scale, what happens is 110 roll number is not valued at 10% more than 100, because 101 and 110 are both only symbolic numbers. That is what we mean by nominal scale. They're just a symbol. Or suppose I say that male is 1 and female is 0, that doesn't mean that women are useless. Okay, so there is no value attached to a nominal scale. It is only symbolic. Okay. In an ordinal scale, on the other hand, there is a value, but the value is only relevant in proportionate terms. So suppose I say that I'm ranking 5 things. We were talking about proteins. Suppose I say that the calorific value of 5 different types of proteins, first, second, third, fourth. Okay. But very often in this case, the difference between 1 and 2 and 2 and 3 and 3 and 4 may not be the same. So in an ordinal scale, you are just ranking them. It is possible, for example, in an Olympic race, the difference between the first and the second runner may be 0.1 second. Okay. So there is nothing which specifies how much is the difference between first rank, second rank, third rank. It is not equal. Okay. So in an ordinal scale. And then you have an interval scale. Okay. Now I said that interval scale, for example, it could be anything. It could be things like income, or it could be any other thing like score in CAT score or anything like that, or stock market, stock prices. So basically, where you have a scale, say, for example, if I'm talking about income, then I'll say how many people are there in the income category of 10,000 to 1 lakh, and then 1 lakh to 10 lakhs. So there's a scale against which I'm measuring. Okay. So therefore this is, and it is a continuous variable. Okay. I hope you understand the continuous variable. Again, this is a bit complicated. I'm not giving this. This would be useful. I'll just show it to you. One second. Can you see the difference between ratio scale and interval scale? This is ratio scale and interval scale. So again, I'm short of time. And absolute scale is where you're simply measuring mostly for weights and volume and such things. Now, at the end, I want to give you something which will be useful, especially if you're doing some kind of questionnaire. I have developed a scale. This scale combines 3 scales. You have a numeric scale. You must be seeing when you when you respond to a questionnaire, you find that please tick 1 to 5. They might say that 5 is best. I mean, feedback. आजकल तो हर जगह feedback आता है. 5 is the best and 1 is the worst. Okay. So I have developed a tool. This tool is combining a numeric scale a verbal scale, and an interval scale. 3 things. By this, what happens is that your respondents' answers become more precise, become more accurate, more reliable. So what is it that I ask somebody that, do you think that the information about life insurance is easy to understand? This is actually from one of my questionnaires. Then suppose I were to give only this 5-point scale, then there'll be an arbitrariness. Some might tick 5, but he might think that is it 5 or 4? I'm not very sure. So I say, to help him, I say 5 means extremely easy and 4 means somewhat easy. Now you think. Okay? And 3 means where you are not very sure. 2 means that it's not so easy. And 1 means that it is really difficult. So I am helping the respondent to understand what is the implication of ticking 5, 4, 3, 2, or 1. So I have combined a numeric scale with a verbal scale, which guides a person to come out with more precise, more reliable data responses. Then again I say, okay, extremely easy would mean what? What are the chances that I would associate with extremely easy? I say, okay,
It will be
100
again
to
subject
8.
matter.
Hello?
It will be again a subject matter extremely easy. That these words
Yeah,
again are
so I'm
matter.
giving another scale over here. This is an interval scale where I say 100 to 81. Then if you place it at between 100 to 81, then you can conveniently choose 5. If you think it is between 80 to 61, these are the chances, then you place it here. So this is something I have developed so that three kinds of scales have been combined into one. And this is so what I'm saying is that if I use this scale, and if different people use this scale, my scale, and they do the experiment in different parts of the country, or they do it for different problems, okay, I believe that this will be an isomorphic instrument, because it is not going to cause distortion. It is going to lead to the same relationship between the empirical space and the image space. That is how I could best try to explain this. I don't have time for all of this. Just one last thing. The different scales are amenable to using certain kinds of statistical tools. For example, if you use a ratio scale, then you can use geometric mean, harmonic mean. If you use interval scale, you can use arithmetic mean or standard deviation. If you use ordinal scale, then you should use median. If you are using nominal scale, which is also called counted data, then you can only use mode. So this table tells you which are the kinds of measures that can be used in correspondence with a particular scale, and also which kind of testing of hypothesis when we do, which kind of statistic can be used. Okay, and also what kind of transformations. So again, I'm very short of time. It is 1:30, and it's a very complex kind of a this thing lecture. So I don't know. I hope most of you have followed.
Any question from the participants?
Sir, I would just like to clarify what we study in sets and relations. Is this only, we start from the source set or the empirical source values, and then we.
I'm not. Can you speak a bit louder? I can't
Yes,
hear.
sir. Sir, what we study in set and relations. under mathematics, sets and relations, is similar, same rather. What we are doing here, we are having empirical values, and then we are trying to create its image, set and relations, which we do.
Okay, I think that may be applicable over here, but what we are talking of, please look at it in a qualitative sense. I only want to say that. Okay, don't look at it in a mathematical sense, although measure theory is a theory from applied mathematics. Okay, but I'm saying that you apply it to your own area. What is your discipline? What do what do you teach?
Sir, I teach physics, and similarly, I also had one. I was the one who asked about the colors. Then I remembered, in, for example, the object-oriented programming, we have C++. There is
Yeah.
a data type enum. So maybe that data type is developed to transform any sequence of colors or any
Yes.
other attributes to number, so that
Yes.
they can be, yes, statistically
Yes. Yes.
studied, modified, manipulated, and recreated. So enum
Yes.
is again a data type. I guess it is for the same reason. I must have developed from this place.
Okay. So to answer your first question, you are technically what you're saying is right. But I'm saying do not, while we are talking about mathematics, we are talking about applied mathematics, try to broaden your understanding of it and don't get into the very precise terminology. Try to look at it in the context of your own research, your own subject, and look at it more in a descriptive way. That's what I'm trying to say. Yes.
Any other question? So I think it's done, sir. So on the behalf of organizing committee, I, Dr. Jyoti Singh, extend our sincerest gratitude for an excellent presentation, sir. Thank you once again for your time, efforts, and for sharing your expertise with us today. We hope to have the pleasure of learning from you again in the future. Thank you, sir.
Thank you, sir.
Thank you. Thank you. I hope you have all benefited from this.
Thank you, sir.
Thank you.
Sir, any book recommendations for this?
No, I'm sorry. That is one thing that I usually don't do. You can search. I'm sure you'll find something. Okay, all the best to you.
Participant, please join at 2. Now you can leave.
Sorry, I missed. कितने बजे का है next meeting time?
2 बजे का, 2 बजे से है ना नया सेशन, नेक्स्ट सेशन 2 to 3:30. ठीक है.
ठीक, thank you so much.
in this basically, yeah, in this refresher program, we shall talk about reference management tools. That is, I'm mainly focusing on Jetaro and Mendeley because the software like EndNote and some there are many software for your reference management. JabRef is there. Many softwares are there. But these two software are free, and specifically if we talk about the Jetaro, it is open source. So in today's session, we're going to discuss why we require these reference softwares. Then I'll talk about Jetaro, how to install, how to word plugin, then PDF annotations are there, how you can import and export your data or citations from, let's suppose, one computer to another or many others. And likewise for Mendeley. And thereafter, we'll discuss about citation styles, and you can create your own, because sometimes in, let's suppose, you are presenting or you are writing paper for a conference, they don't have standard citation styles. They give this way, and you have to make every reference like that. So in that case, you may learn in today's session how to create these self-citation styles, and thereafter then we'll compare different reference management tools. So this is for today's. So why we require a reference manager? Because we all are the faculty, and we are somehow have to either complete or we have completed our PhD. So in our PhD, we are going through many research papers, then books, then articles, and earlier times we are taking printout and we are organizing in bookshelves. And since the information is a lot more today, and we are facing difficulty in organizing, especially when data is online, because a lot of paper can be stored within, let's suppose, 10 MB, 20 MB of storage, and somehow we have read some paper, we have taken notes from it, but if it goes away, then it is we are not able to recall from where we have taken that notes and citations. So it helps in organizing or store or manage your bibliographic references like book, journal, etc. And somehow you will going to see within a fraction of a second, it will going to change the citation formats. For example, you have written one paper for a IEEE journal, and somehow the editor says that this paper is out of scope, क्योंकि बहुत अच्छी तरीके से वो लिखते नहीं है, but somehow they say this paper is out of scope. Then you are writing, then you are making the format change, and you are making that paper which is suitable to, let's suppose, Springer. And Springer, they are that particular journal says that we want reference in this way. Then either you spend a lot of time and make those citations or references in that format, or now we are going to learn, and I'm sure that many of you are using these reference managers also. So by clicking, just by click, you can change the particular format. You can import references from a database from, let's suppose, Google Scholar, from IEEE Explorer, PubMed, or any database. You can easily import reference, and you can insert citation directly into word processor. And it can also help in reference sharing and collaborate. See, somehow people who are working in LaTeX, there are some online platform where each one of author can work simultaneously. Similarly, we have Google Doc. So with the if we can share the Google Doc with our collaborators, we can work simultaneously. But how to manage reference in that? So for that, we have Jetaro. I think it is the only software which work with Google Doc also that you will going to learn. So it is very important for academic writing because it saves lot of time. Because as I told you, automate citation, bibliographic formatting, reduce manual errors. Not only errors, it also increase our efficiency because we have to just see whether we have done it rightly or not. Otherwise, if you may find something, then you can correct that, and that correction will be automatically updated in the latest versions. So it improves organization of, or basically storage of references at one place with easy retrieval. Allow tagging, annotations, categorizing, everything. In fact, it helps you in switching from one citation format to other. And you can always integrate with research tools like I'll show you in the coming time that you can import references directly from academic database like PDF you have, then you just put it there. It will create its database directly. So work with MS Word, Google Doc, LaTeX. So it help you to avoid plagiarism and mainly help you in literature review, because at the same time you will do quick searching, filtering the resources, and many more. So first of all, I'm going to discuss about the software Jetaro. It's a free and open source. That means there's no cost involved in that. Any person who is willing to develop that software can develop that, or willing to use it can use it. It's a standalone software. You need not, like in Manley, you have to create your account in MS Office also, Manley also, and then only you can work. Although you can work offline also, but somehow you have to start with an account. Here in this software Jetaro, you can work in a standalone. It work in cross platforms, like you can work in Windows also, MacBooks also, Linux also. In other software, there is a limitation. So you can integrate that Jetaro software with your browser. For example, either you work in Chrome or then Mozilla, Firefox, basically. Whatever browser you are working, you may find an extension where just by clicking on that, automatically your database paper can be downloaded and can be stored. It can store PDF, you can take notes, you can prepare a metadata in your customizable and affordable collection, and that too clearly quite easily. I'll show you. And it has supported more than 10,000 citation styles. That means whatever you are thinking about a style, you may find almost 90% similar to that, and you can further tickle it or change it, and you can work with particular citation format. Although Mendeley is giving 2 GB of free spaces, but this Jetter's software is giving only 300 MB storage for your reference synchronization. That means if you want to work online, then it can store up to 300 MB for free. If you want further, then you have to pay something and work. You can collaborate. Collaborations could be done between the library. PDF management can be done through annotations, offline access without internet. You can work, and there's lot of plugins and add-ons are there, so that you can work with LaTeX simultaneously, work and so on. Just to tell you the brief history of this Jetero software, it is launched by the Center of History and New Media at GM University. And it's a standalone version released in 2008, and Jetero 2.0 is released in 2010 with cloud synchronization group collaboration. After that, this software is keep on changing and modifying, and today you are using, you may use Jetero version 7. So without making this lecture monotonous, I'm giving you, if anybody want, then they can have hands-on training also. So I'm taking you to this software. So quickly, can anybody tell how many people are using this software? Anybody who is using this software?
No, sir.
No. Okay. Yeah. First of all, just type jet arrow and just put enter. You can see the website jetarrow.org, your personal research assistant. Just click on that. You can see that there are many versions of Jetaro is there. Likewise, if you work on Windows, then there is Jetaro 7 for Windows and older versions. So I request, if you want to download, then download Jetaro 6, not 7. 7 is the latest one, because somehow this is open source. And in open source, what happened, like the person who are working in Linux also, the latest version may not be compatible with your older applications. For example, annotations and all is compatible with Jetaro 6 and below, because Jetaro 7 is just come now. So it may not be compatible with that. So you just click on Jetaro, and if you want to install for Windows, if your system or operating system is Windows, then you can do it for Windows, otherwise Mac also and Linux. So if you click on here, then similarly, a 59 MB software would be downloaded. And then let me close it and let me show you. If I go to download buttons, I'm visible, I think.
Yes, sir.
Okay.
Yes.
Then just click on the jet arrow and follow the instructions. It's quite simple and you can easily download it. So without wasting your time, since I have already installed it, I'm not installing it. Otherwise, you may install as you wish. So it will take hardly 1 minute or 2 minutes, because this is open source software. So I'm taking you to this software. Now, something like this jet arrow will be there on your desktop, and you are requested just to close any Word application if you have, because it automatically give a plugin of Word plugin to the Word. If it is open, then it will ask you to restart the system and so on. So for demo purpose, just I am explaining you here that in this is a library where you can create one type of research papers here. Then to create that, just below the file, there is a option folder. You can create the folder. Let's suppose I have created it, my demo D, this, and this is quite empty folder. Nothing is there. So, and you will see the desktop like this. Here you have library, then you can see that there are creator, year, publication, title. So you can change them also. If you want year first, you can just pick this and drop here. And if you want publication first, then pick it here. So just to demonstrate you, I'm dividing this into 2 parts. Let me put it here so that you will not going to disturb. So let me go to a download folder. And in download folder, let's suppose if let me go to some folder where I have put some papers. For example, these are I have a folder where I have a lot of research papers. What you require to do, just pick one or many and then drop it here. बस उसके बाद ये खुद काम करेगा. You can see कि ये download हुआ and after that it create its own metadata. आप देख रहे हो कि let me show you. मैंने just ये pick करके यहाँ डाला था with different name. इसने name भी change कर दिया and it has noted from the it has taken the metadata from the PDF, that who is the authors, in which year it published, which journal it published, what is the title, and if you want you can add more tabs where you contain more information, and in right hand side you can see all the information. It's a journal type article and these are the authors. If you want to include abstract, usually you don't need abstract in the references. So divide number to each and everything it has extracted. So this is the example where I have taken only one. And if let's suppose if I'm taking 1, 2, let's suppose 3, 4, 5, 6. And I'm putting them all together here. So you can see all the 6 papers with these names are here and sequentially it is creating their database. And after this green symbol, you have to just close. So you have noticed that this is the paper, all information are there. Somehow in some database or while some PDF, some information may not be there. There you can add it and you can add. For example, 192 issue, if issue is not there and you know that, you can just put 5 and similarly. And you might have noticed that the second and third are almost same. Almost they are same. So what you can do, just type in not in fact these two are also same. So just to go to duplicate files and here you find all that which are duplicate, not only in this, wherever. So you can duplicate files, just click on there, merge files. Just click merge. So just click merge. So we are interested in those Pankaj Rakheja and oil in merge. Because all those papers are already there and so I think one step is clear to you that how you can create the database by using earlier database that you have. That means if you have a folder, you have a lot of soft copies of your paper, you need not to worry about that. Just pick them and drop it here. It will automatically, if you connected with the internet, it will automatically create their database. Otherwise, somehow if you are not have internet, then only that file will be, you will show that file. And from that file, if you connect later by internet, then it will going to create everything. See, you can see paper is there. In every folder, paper is there. So,
excuse me, sir.
Yeah.
Sir, I have missed some of the steps after installing Zotero. Can you please quickly revise the steps once again?
Okay. See,
Thank you.
What you require to do, just open, let me create a new, let's suppose my demo 2. Let me create a folder. In this way or simply in library, you can create a folder. In folder, There is nothing like that. So I have just told you one thing only. That is how you create the database from your existing database. That means you have a folder that contains lot of research paper. So what you do, for example, I'm just minimizing its size and I'm going to on. Okay. Let me do it. So yeah. Let me. So likewise, you are here. So if you have a paper in folder or in desktop, just pick that paper and drop it here. Rest, it will do it itself.
Okay, sir. Thank you.
You can see that this paper has been given here, and itself it has created its database like author, year, publication, and title. It totally depends upon you if you want further more detail or you want that creator must be here, publication must be here, then you can and you can play with it. For example, you want year first, then author, and that's all. And this is not only you can put the single, you can put the many one. And suppose if you want to put them in a chronicle order, then increasing and decreasing you can find. And if you click on the creator by name alphabetically, it will do. If you put title wise or by publication wise, so you can do whatever sorting you want to do. So this is the first thing. Now I'm just giving you a demonstration how to use it. Okay. So I'm opening any Word file, although I have created one file for, let me take, yeah. This is a simple Word file. I have not written a single line in it. This is open file. I'm creating, let's suppose, in this, let me go to use AI. Chat one. In this, I'm writing, let's suppose I want 10 lines. Okay. 10 lines in paragraph form about gender. And just click, see, by using this, I'm just creating 10 lines. So suppose this is your research paper. Okay, let me increase its font so that you can easily see it. Whatever format, whatever line spacing you want, you can do it. Okay. First thing I'm clear that let's suppose this is your research paper. And you want to insert, let's suppose, one reference here. So by installing it, you can see that Jetara extension is been installed in your Word file. And if you click here, you can see many tabs: add and edit citation, add and edit bibliography, insert notes, document preferences. I'll tell you one by one. So first of all, click on add and edit citation. Then it will ask which citation you want. Let's suppose I want IEEE or I want ACM, let's suppose American chemistry, and you put OK. Then here, this tab will be open and you write any research paper. Let's suppose I'm writing such it. So whatever research paper you have stored in your Jetara file, they will come here. Either you can write the your title of the paper or author or journal name, whatever. Let's suppose I'm clicking this and I'm entering it. So you can see that this number appear, and here after and I'm writing references and you want that references should be here. So what do you do? Just click on add and edit bibliography. So you can see that that paper name with ACM format is there with DOI, with title and all. And suppose I want to insert 2 more citations. So again, choose the place where you want the citation, add, and you can simultaneously add 2 or 3, whatever you want. Let's suppose if you want Ravi, 1, Sachin. So I have taken 3 citation and just put the enter. So you can see that it has created the database. See, reference 3 has many authors, and in this author format, they don't put at all. Therefore, you are getting this. Now, somehow you want to change the citation style. From this, you want something else. So to do that, what do? You put your icon on document references and just clicking on anything. Let's suppose Elsevier, Harvard, put OK. Then you can see within a fraction of a second, it has changed. K as alphabetical order, and you can see. So whatever the format style you want, you can play with that. I have taken IEEE, if more than say 5 authors are there, they put at al. So you can see that these are 4 papers. So that depend upon the journal also. So whatever style you want, you can choose. See, you have seen that one in IEEE it is showing 2, then 3, then 4, and here it is showing 2 to 4. So it totally depends upon the software, sorry, journal citation which you want. Now the next question is first question I think I have answered, that how to install Jetero. Second question is how to add the database. The one way is if you have a folder, then just put that folder where PDFs in here, and it automatically extract the database. Now go to the website in Jetero also. Then you can see that there are many connectors. For example, I have opened this Jetero folder in Edge, Google. So it has created a Jetero connector. Install Edge here. Otherwise, just put Jetero from connector. So you will find the extensions. Just click on get. So what happens is if you install this plugin, then here whenever do you research, then you will find something here. For example, I have already installed it. If anybody want, they can just put get or connect. If they have Firefox, Mozilla, then they can do that. If they have Chrome, then they can get Jetero Chrome connector. If they have as whatever browser you have, you can easily connect with that. So now what you have to do with that here, let's suppose, let me go to Google Scholar. Just put enter. So anybody want papers from their field, they may let me know. Whatever you want to let me search. Any field
Microemulsion.
Sorry,
Microemulsion.
micro emulsion. Let's suppose I have written this title, and you can see that a lot of paper are appearing. Some are having PDF and some don't have. Let me take this first one. Due to One Nation One subscription, I can download it. But see, you can see that this symbol has changed and it has written something like this. आपको कुछ नहीं करना, just click here and go to your nano emulsion paper is there and they have downloaded it. Is that okay?
So
Let me
please
demo.
explain
Yes,
again.
sir.
Okay. See, any paper, just Google it, go to their homepage, and you want that this paper should be stored in your Jotaro database. If it is PDF, then you will get PDF. If it is something else, I'll show you that also. If you want to save this, just click on here. Save to Jotaro. Just click here, and it automatically goes to Jotaro file. So this is the current folder. This paper come, and either it will create its metadata itself, or you can ask for. So you have seen that this paper database has been created.
So that means once we have added this plugin, so it is
Plugin,
since
then
we
you
have
can easily store any database or any research paper you want.
we would get this icon directly to and which will direct
Yeah.
us to the Zotero.
So you need not to type. For example, this is a paper from Science Direct, and although I can view PDF here, but it is not open. So you can see that there are some lines like a test, like data is there. Just go and click on that. If you click on that and go to your Jotaro file, that paper will automatically reflect in this folder, which folder you are working. Yeah, this is the paper.
So you mentioned something about the size. So is there some limit to the number of papers that we can say we all wrote?
There are two things, ma'am. If you are working standalone, that standalone means आपका कंप्यूटर आप हो, तो इसमें कितना जीबी टीबी कुछ भी कर सकते हो. लेकिन जब आपको कोलैबोरेशन करना है, यदि गूगल डॉक यूज करना है, कोलैबोरेटर्स आपके बाहर हैं और वो भी सेम डेटाबेस को यूज करना चाहते हैं, तो उस केस का भी मैं सॉल्यूशन बताऊंगा. 300 MB इज द लिमिट फॉर दैट. बट स्टैंड के लिए कोई लिमिट नहीं है, आप कितना भी कर सकते हैं, कोई किसी भी साइज का पेपर ले सकते हैं.
ओके, थैंक यू सर.
तो अभी तो सिर्फ मैंने आपको स्टैंड अलोन ही बताया है. अभी गूगल डॉक पे मैं ले जाऊंगा आपको थोड़ी देर में, और आपको सिंक्रोनाइज करना है तो ये क्लिक बटन है, इस पे क्लिक करेंगे तो ये आपको इट वांट कि आपका एक यूजर नेम हो, आपकी एक ईमेल आईडी हो, एक पासवर्ड हो. उसके बाद फिर आपको आपका जो डेटाबेस है वो सिंक्रोनाइज कर देगा अपने क्लाउड में, एंड देन आप कहीं से भी उसको एक्सेस कर सकते हो बाय यूजिंग योर यूजर नेम एंड पासवर्ड. दैट्स हाउ यू डू इन मेंटली, सिंपली ऐसे. तो आई थिंक अब देखो ये डिफरेंट
सर क्या हम
डिफरेंट
लेटेक फाइल में भी इसका यूज कर सकते हैं?
बिल्कुल लेटेक में कर सकते हैं. मैं आपको एक्सपोर्ट,
लेटेक,
हाँ लेटेक में यूज कर सकते हैं. आई टेल यू कैसे उसको एक्सपोर्ट करना है फाइल को. वो इंपोर्ट एंड एक्सपोर्ट में आ जाएगा. लेटेक के लिए यूज कर सकते हैं. वर्ड के लिए तो आपने देख लिया. अब लेट्स सपोज मैंने ये पेपर नैनो एमल्सन यूज किया था, एंड आई वांट टू यूज समथिंग हियर. लेट्स सपोज आई वांट टू पुट अ साइटेशन हियर. So let me repeat this again. You have to just go to edit citation button and put nano emulsion, if I'm not wrong. Nano. Okay. So you have seen that only nano type papers are there. So this paper we have just uploaded in our folder. And if I put enter, you can see that this paper appear here. And citation 5. And if you want to change that I told you. Just put OK. Now see, alphabetically it has taken, for example, Nana Wilson, the author start from A, so it has already taken A, and alphabetically it has done that. So in this way, if you want to change style from one thing from from one format to other format, you can easily. So this thing is doable. So it's quite clear. Anybody has any doubt in this?
No.
Sir,
Yeah.
sir, in the second line, could you please delete Sachin Singh and
Yeah, I
Sachin
can
Singh
do
and
that.
Singh
Yes, very good
2023?
question. Suppose somehow you have marked wrongly, then click on select that citation and add an edit. And I want to delete Sachin. I have deleted it. I've entered it. So you can see that one Sachin has gone.
And sir, could you please delete from the second line Sachin Singh and Singh 2023 and please show the changes in the references?
Okay. I'm just clicking here. Here, only one thing.
Yes, sir. Please delete this and please show the changes in the references.
One more way you can do it.
Sir, if you convert this Sachin Singh and Singh 2023 to numeric number that is 1, 2, 3, 4, the one which you did earlier, if we delete
Ma'am, the thing is, the numerical number has been done through this citation style section.
yes, sir, exactly.
Let me put Ravi here. Ravi Bhadra paper already taken, then Archana. See, Archana paper is there. Now, what do you want?
Sir, I want the numeric number that is 1 in the square bracket.
See, that totally depend upon the citation style. If
Yes,
you
sir,
want
exactly.
IEEE, then click OK. Then you can see that it's 1, 2, 3. Then
Sir. So now if you delete 1 from the second line, will the reference automatically get deleted and it will change the numbers of the other references accordingly?
Yeah, it's automate. Let me explore that. मैंने अब कभी किया नहीं ये चीज.
Yes, sir, please. If you delete 1 from the second line.
Let me see. I have a trigger.
Yes.
And let me refresh it. Okay, ma'am. Automatically it's become 1, it's 2, and then it's
okay, fine, sir. Fine. Okay, sir. Thank you so much. Thank you.
So I've told you how to get your data data from PDFs, then from internet, and now I'll tell you how to modify that. So I have a different order. If you want to sort in increasing or decreasing order, you can do that by creator also. You can do it by title also. You can create the database as per sorting you want. Other thing is sometimes somehow what happen is, let's suppose journal name is not coming full, then you have to type it here because this is an open source software and you require to do some editing part. But it happened in, let's suppose, one case in out of 100, and that journal is not that standardized. In that case, you have to edit. Otherwise, usually it extract very good metadata from the research papers. Then if third thing which you have already know how we are creating the folders. Duplicate entry, just if you put here, then you can see the duplicate entry. Just click on anything and it will ask for merge. You just merge them. It will going to merge. So by this, you eliminate your duplications thing. So that somehow what happens is in one format you have made changes, in another another place you have not made changes. Then somehow by software, it may take some correct citation, or it may take some different citation. Okay, this is about Jetero. Now I'm taking you how to take import and export files. Suppose if you want to take only one paper at a time, or if you want to take whole folder at a time, it totally depends upon you. For example, I have taken this folder. It has contained, let me take demo only. So you have seen that it has 3, 6, so 9, 10 paper are there. So just go to file and export library. In file button, you may find import and export. In export, you are seeing two options. There are various formats you can. Those who working in so-called LaTeX, they require BibTeX. I think आपकी problem solve हो गया होगा ना BibTeX का नाम देखकर.
Yes, sir.
Okay. So I'm putting. So if you want कि आपके पेपर भी साथ में जाए, रिसर्च पेपर जो आपने PDF में सेव किया था, so you can export the files. And if you want कि आपके पेपर नहीं सिर्फ उनके टाइटल और ये सब कुछ जाए, मेटा डेटा जाए, पेपर फाइल के फोल्डर बड़ा हो जाता है. तो दैट्स व्हाई आई एम टेलिंग यू कि जब आप गूगल डॉक के साथ सिंक्रोनाइज करोगे, किसी और सॉफ्टवेयर में गूगल डॉक के साथ नहीं है, सिर्फ जेटेरो में ही, तब आप इस फाइल के बटन को क्लिक ऑफ करके इस डेटाबेस को उधर डाल सकते हैं. चलो कोई नहीं, दैट्स अलग स्टोरी. सो व्हाट यू डू, जस्ट पुट ओके. सो इट विल आस्क वेयर टू स्टोर. So you can choose your own file name. For example, in download button, I have created, I suppose I have created, Jetero backup. So I'm storing it with the name my demo view. Okay. You can store it with different name also. Put yes. So you can see how quickly it do. अभी time ले रहा है, otherwise it is quite fast. It can do the merging within time. Okay. So see, if you go to that folder and download, you can see my demo du folder has been created, and in this folder you will file a RDS framework document and files. In files you can see many papers, and papers you will see many things. So your work is that this is the file, and this is the way you can export from Jetero. And now I want to import it. So before importing, okay, still working. What happened? I am visible, audible?
Yes, sir.
Because my screen is not responding. So let it take 1 or 2 seconds.
सर लाइट है थोड़ा सा वो, उसमें भी प्रोसेस.
Let me cross it. Yeah, somehow I have closed the Jitterer file and I'm relaunching it. So this is the folder in which I am working, and I want to delete it. I delete collection. So you can see that I don't have that folder. Now I want to import that. So go import. So it asks you whether you want to install from BibTeX, RES, JIT or RDF, etc. Then next, then it asks where it is. So this is my folder and this is the link. Just open it, copy file to Jotaro sorted folder, link the file to original location. Okay, next. It will start importing. You have seen that it has created a folder which is my demo du. मैं इसको डिस्टर्ब नहीं करता क्योंकि पिछली बार भी बंद हो गया था. So let it complete. See, somehow maybe some updates are installing here, not of Jetaro. It is quite fast. Let me tell you, it will do fraction of seconds. So all that file that you have will be created here. So in this, the thing is that you can easily import and export any database that you have from one computer to another, or from one folder to another, or you can merge them. You can do whatever things you want. Importing. It is taking fast time. Okay, let it complete. Then let me discuss the next problem. Next problem is that although we have 10 to 12 formats, and somehow a journal asks you with that particular format. And in the beginning, I told you that it supports more than 10,000 citation format. Then how to access them and how to install in your data JTARO file. Although it has started. So next we're going to discuss how to import a citation style to your JTARO file. And then we'll talk about the PDF annotations, and later on we'll discuss how to create your self citation styles. What happened to it? Don't save. Let it do. So my demo. तो तभी प्रॉब्लम आ रहा था कि बिकॉज इसने सारा सिलेक्ट कर लिया, दैट नॉट पर्टिकुलर दैट फोल्डर. सो इस फोल्डर पे मुझे एक्सपोर्ट करना था. मैंने फाइल में जाके एक्सपोर्ट फाइल किया था, एक्सपोर्ट लाइब्रेरी, मुझ पर क्लिक हो गया था. अदरवाइज व्हाट यू हैव टू डू, लेट मी शो यू अगेन. जस्ट डिलीट दिस, डिलीट कलेक्शन. That's why it is not responding in that way. So I want let's suppose I want this is the folder which contains, let's suppose, 10 to 12 references. If you want to export that, then click right click here and just export collection. It will ask the formats, put OK, and wherever you want to store, then store. Okay, I already have. Then let me share this is ECC1 and save. So within fraction of second, it will be stored in ECC format. And again, if you want to import that, just go import next and ECC1 open and next. You will see within fraction of second, you can see that this has started working, and within fraction of second, you can easily import or export your database where you want. Is that clear now? And you can see full paper is there. Okay, next is go to edit and click on preferences. Just so you will see many options here. One is first is journal, where while downloading from page you want a screenshot. If you want, you can put automatically attach associate query file. If you don't want, so these all play and plugin buttons, you can get this. Next is synchronization, where you require a username and password. So you can link with your standalone or you can unlink it. Then there's a search button, export button. So format, links, whatever you want, you can create or you can sell. So important thing is site. So you have seen that in my edit bibliography button, I have this much of citation style. And I told you that I have more than 10,000. To get access, what do you do? Get additional styles. Another tab will open and you can see lot of journal citation styles are there. For example, can anybody want to test whether their journal is there or not? Let me have their journal name. Tell me any journal name.
Physical review D.
Physical. Yeah, physical review D.
Yes, sir.
PHYSICAL. CAL, okay. Physical review. Yes, physical review B, C, D सारे हैं. और देखो D का फॉर्मेट ये है. Okay?
Yes.
Here.
Yes.
और फिजिकल रिव्यू डी आपका ये आ गया. ओके. एंड अभी जो हमने थोड़ी देर पहले काम किया था, लेट मी सी कि हमने फिजिकल रिव्यू डी में कर सकते हैं या नहीं. ओ सॉरी, वो सारा चला गया है, बट 1 मिनट लगेगी मुझे. Let me increase its font from 14, then take this file. If I'm adding here, just go to jet arrow button, add here, physical review D. Okay, and put any author, let's suppose reference of Jagrati. ये 1 आ गया, और यहाँ जाकर either put reference or just click here, add bibliography. तो ये physical review D का फॉर्मेट है. Is that okay? So,
sir, 1 second, please.
Sorry?
1 second, sir, please.
Okay. Meanwhile, let me do one more thing. Let me put 2 or 3 or more citation. इसलिए मुझे याद रहते जल्दी. So this is applied physics D. Sorry, physical review D. Citation style. and somehow you want to change from physical review D to, let's suppose, optoelectronic advances, you can see change. You again want, you can see that it will be like this. You again want physical review D, and later on you can whatever you want, you can do that also. Is that okay? अब next phase पे चलें हम?
Okay, sir.
Okay. This is the way. Let me tell you once more. हमें करना क्या है? जटारो पे जाना है. जटारो से preferences पे site पे. If it is not here, just click on additional, get additional styles. एक page open होगा, and there almost 90% और 95% जर्नल्स जो क्वालिटी जर्नल्स उनके साइटेशन स्टाइल यहाँ पर है. आपको जस्ट क्लिक करना है और ऑटोमेटिकली रेफरेंसेस उसके अकॉर्डिंग हो जाएंगे. आपको कुछ नहीं करना. ओके, नेक्स्ट थिंग इज लेट्स सपोज साइटेशन.
Sir, we have to now take, it means Zotero 6 as well as Zotero extension, Chrome extension.
हाँ, Chrome extension.
Both are required. It means we have to download both.
Yeah, both are required.
Okay, sir. Thank you.
Okay. So you have the problem that how to reference or data, have how to maintain your database. That problem is solved. Then how to download or the papers, that is solved. Third thing is citation style. That problem is also solved. Now fourth is you have lot of papers, and the problem is that what you do. पहले क्या होता था कि हार्ड कॉपीज आर देयर, मैं उसमें कुछ इंपॉर्टेंट लिखता था, कभी टैग लगा लेता था कि ये इंपॉर्टेंट फिगर है, मुझे यहाँ पर मिलेगा, और फाइलिंग कर लेता था. अब जेटारो में सिर्फ ऑफलाइन है, सब कुछ ये है, तो मुझे ये कैसे करना होगा? उसके लिए उसका सॉल्यूशन है जॉट फाइल. सो गो टू गूगल एंड राइट जॉट फाइल. एंटर. जॉट फाइल ओपन होगा एंड जस्ट क्लिक ऑन डाउनलोड. जैसे आप क्लिक करोगे डाउनलोड को, तो एक छोटा सा फाइल आज ही सुबह मैंने किया था. यू कैन सी जॉट फाइल है कहीं, एक जॉट फाइल जो सिर्फ 468 KB की है, वो एक एक्सटेंशन ओपन होगा. क्लियर? जॉट फाइल का एक्सटेंशन अपीयर होगा XPI फाइल में. अब आपको इंस्टॉल कैसे करना है? गो टू योर जेटारो, view tool on, go to tools, and there you can see add-on button. In add-on button, go to the setting. In add-on button, go to the setting, install add-on from files, and here go to download, and in that file just click here, open. Since I have already done it, so it appear like this. Then system would like to have a restart. It's important. System would like to have a restart. Okay? बटन फिर से बताऊं एक बार मैं आप लोगों को. Go to tools, go to add-on. In add-on, go to setting, install add-on from file, and then choose that file. For example, I have it here, and just click open. It will automatically install within fraction of second, and you have that extension. So what is the use of this extension? Let me tell you now. See, let's suppose this is my paper. In Jetaro only, click here. This paper will appear. And I'm start reading. And मुझे पसंद आई ये लाइन. Jotaro plays an important significant role security. Just ये select कर लिया, highlight कर लिया from here, and then let's suppose मुझे ये लाइन भी पसंद आई and I want it in different color, तो different color में भी कर सकते हो, same color में करना same में कर सकते हो. So in this way you can highlight any PDF. Apart from them, let's suppose मुझे figure A पसंद आया, मुझे कभी reference के लिए use करना है, I have to take note out of this. And in this equation, let's suppose I want to comment. This is important equation. You can add tag to it or just here. किया, इसके बाद मैं फाइल पे गया और इसको सेव एज किया. सेव एज उसी के नाम पर उधर ही करके बस सेव कर दो. ओके, अब मैंने इसको क्लोज कर दिया. ऐसे मैं बहुत सारे फाइल्स को कर सकता हूं. फॉर एग्जांपल अभी मैंने ये किया. अभी जस्ट राइट क्लिक करो इस पे, what happened to it? ये फाइल ECC का फाइल था, ये फाइल था. ओके, ये फाइल था मेरे पास और इस पे मुझे क्या करना पड़ा, ऐड नोट्स फ्रॉम एनोटेशंस. विच फाइल इज दैट जिसमें मैंने काम किया था? इस पे किया था? नहीं, इस पे तो नहीं था. इस पे किया था? यार इस पे किया था मैंने काम. ओके, सो आपको करना ऐड एनोटेशंस. एनोटेशंस ऐड होने के बाद में अब आपने ये लाइन इंपॉर्टेंट लिखा था, आपको उसके लिंक पे जाना है, तो इस पे क्लिक करो. सो ऑन द पेज कि कहाँ पर आपने ये लिखा था. यहाँ पर आपने ये लाइन सिलेक्ट किया था, इस पे क्लिक करो, शो ऑन द पेज कि पेपर में कहाँ पर है. देन ये फिगर था, शो ऑन द पेज, दिस इज द फिगर. एंड देन लास्ट में मैंने कुछ कमेंट लिखा था इस लाइन पर, दिस इज इम्पोर्टेंट, गो टू द पेज. सो इन दिस वे बेसिकली you can use annotations. Annotations means notes आपके PDF से. ये तो एक पेपर है, लेट्स सपोज आपके पास 100 पेपर्स हैं, तो आप जस्ट क्लिकिंग ऑन एनोटेशंस. अब आपको बार बार ये करने की जरूरत नहीं है, आपकी बार एनोटेशंस फाइल आप ऑटोमेटिकली आ गई. फॉर एग्जांपल लेट मी गो हियर, कोई एनोटेशन फाइल नहीं है, इस पे जैसे क्लिक करूंगा ये आ गया, और इसके एनोटेशंस पे जाऊंगा जो मैंने इंपॉर्टेंट लिया था, दे विल ऑल हियर. You can add notes also. You can do whatever things you want. So things बहुत बहुत ज्यादा हैं, चीजें बहुत ज्यादा हैं. एक्सप्लोर जितना करोगे उतना ही समझेंगे आप लोग. इसके बाद मैं एक डेमोस्ट्रेशन दे रहा हूं आपको, हाउ टू सिंक्रोनाइज दिस विद गूगल डॉक, जो इस डेटा को और इम्पोर्टेंट बताता है. सी
Yeah, excuse me sir, can I have a query. Sir, मैं जब Zotero अपना ओपन कर रही हूँ, वहां पे मेरे पास टूल्स में एड ऑन नहीं आ रहा है.
वर्ड में नहीं आ रहा है, कहाँ पर नहीं आ रहा है?
Zotero का जो होम पेज है उस पे करना है या वर्ड पे करना है? ये
आपको चाहिए क्या है, मतलब
एड ऑन, ये जो आपने सॉर्ट फाइल वाला बोला था सर,
ये चीज ये नहीं आ रहा है. ये चीज नहीं आ रहा, क्या नहीं आ रहा आपका?
सर जॉट फाइल का जो उसमें एड ऑन करना है, मैंने डाउनलोड कर लिया वो, पर यहाँ एड ऑन से जाके क्लिक करके करना था ना, वो नहीं आ रहा है.
आपने Zotero 7 डाउनलोड किया, कौन सा किया है?
ये सिर्फ 7 में है ऑप्शन क्या? मैं देखती हूँ सर कौन सा है.
मैंने इसलिए स्टार्टिंग में कहा था कि आप Zotero 6 डाउनलोड करें, जब स्टार्टिंग में डेमोस्ट्रेशन दिया था ना. जब डाउनलोड की बात थी तो 7 को छोड़कर 6 करना था।
ओके सर, मैं चेक कर
7
लेती हूँ।
एक्चुअली जोड़ फाइल के साथ कंपेटेबल नहीं है राइट नाउ। हो सकता है 2 महीने के बाद हो जाए क्योंकि डेवलपमेंट चलता रहता है, आज के दिन नहीं है। तो दैट्स व्हाई
ओके ओके, ठीक है सर, ओके, थैंक यू, थैंक यू।
वो करना है। ओके, वेयर आई एम
सर गूगल वर्ड, सर ये वर्ड डॉक्यूमेंट में कैसे आएगा जोटेरो कनेक्टर का एड ऑन?
एड ऑन डायरेक्टली आ जाता है जब आप इंस्टॉल करते हो ना। गूगल वर्ड को क्लोज करके रखना जब इंस्टॉल करते हो, तो ऑटोमेटिकली जब आप वर्ड ओपन करोगे तो आ जाएगा साथ में।
ओके सर।
और नहीं आता है तो स्टेप्स हैं, आप जस्ट गूगल करो कि वो स्टेप बता देंगे कि ऐसे कहाँ पर एड ऑन ऐड करना है, वो आ जाएगा, उसका कोई बड़ा इशू नहीं है। अब इंपॉर्टेंट क्या है कि जो जेटारो को सबसे अलग करता है दैट इज यूज ऑफ, लेट मी टेक ए फाइल। मैंने ऐसी सिमिलर सी मैंडले, ओके मैंडले बताना आप लोगों को कितना टाइम रह गया है। ओके, लाइकवाइज इसमें भी आपको कुछ नहीं करना। जैसे नॉर्मल टेक्स्ट में किया था वैसे यहाँ पर आओगे, आप क्लिक करोगे, देन पुट जेटारो। इसमें एक्सटेंशन इस टाइप से मिलेंगे, उसमें तो बटन्स मिल रहे थे ना, ऐड एडिट साइटेशन, ऐड नोट्स, बिब्लियोग्राफी, डॉक्यूमेंट प्रेफरेंसेस, वही सब कुछ। सो लेट्स सपोज मैंने ऐड साइटेशन करना है। हियर आपको एक बार लॉगिन करना होगा, आप स्टैंड अलोन काम नहीं कर सकते। हियर यू हैव टू लॉग इन योर जेटारो अकाउंट। आप देखोगे ये पूछ रहा है, लेट्स सपोज कौन सा पेपर था वो,
Sir, something cryptography.
क्रिप्टोग्राफी नहीं, जो सेव है CRYP, लेट्स सपोज अंजना एटाल, दिस इज द पेपर। ओके, ये तो ऑलरेडी मैंने कर लिया है, इसको नहीं। एनी पेपर दैट इज इन योर डेटाबेस एंड यू हैव स्टोर्ड इट, इसे क्लिक करोगे आप। ये थोड़ा सा बिट स्लो है, बट ये यूं है कि आप साइमल्टेनियसली आपका कोलैबोरेटर भी वर्क कर सकता है, एंड दिस आल्सो वर्क हियर। ये मैंडले में फैसिलिटी नहीं है जो आप यहां पर देख रहे हैं। व्हाट यू रिक्वायर टू रिक्वायर हियर इज फर्स्ट कि आप अपना डेटाबेस बनाओगे, देन उस डेटाबेस को इस बटन से सिंक्रोनाइज करोगे। ये सिंक्रोनाइज होगा ऐसे घूमकर, उसके लिए आपका अकाउंट पूछेगा, अकाउंट बनाना पड़ेगा। सिंक्रोनाइज होने के बाद में आप जो चीजें आपके यहाँ पर है वो वही सारी चीज आप यहाँ पर भी डायरेक्टली यूज कर सकते हो। फॉर एग्जाम्पल डॉक्यूमेंट प्रेफरेंसेस में लेट मी सी कि वो जो रिव्यू, फिजिकल रिव्यू डी आया नहीं आया है, लेट मी चेक। डी आ गया, देखो ये अब ऑनलाइन कर रहा हूं मैं, ओके किया। नाउ दिस इज फिजिकल रिव्यू डी साइटेशन स्टाइल। इसमें प्रॉब्लम क्या होता है कि आपको ना लगेगा कि यहाँ पर कुछ नहीं हो रहा है, लेकिन साथ में एक और विंडो बन जाएगा जैसे अभी किया था ना। फॉर एग्जाम्पल हियर इफ आई वांट टू ऐड साइटेशन, अब आपको लगेगा ये अपडेट हो रहा है, लेकिन आप जाओगे तो यहाँ पर देखोगे कि यहाँ जेटारो। ओके, वन वेरी इंपॉर्टेंट स्टेप इज वॉट एवर यू डू, आपको जेटारो ओपन रखना है, अदरवाइज वर्क नहीं करेगा। जब वर्ड का डॉक्यूमेंट ओपन करोगे उससे पहले जेटारो को ओपन रखना है, अदरवाइज वो चलेगा नहीं प्लग। दैट्स वेरी इंपॉर्टेंट। सो हियर लाइक Javedi, let me put here. So if you want to change style, go there, एक बटन अपीयर होगा, whatever you want, and it will change. तो जो नॉर्मल वर्ड में करते थे वो आप गूगल डॉक पे भी कर सकते हो, and simultaneously your supervisor can see it. Okay. I think this is all about Jetero. मुझे फटाफट मेंडले कवर करना, उससे पहले एक बहुत इंपॉर्टेंट है जो शायद ही कोई बताएगा आपको, दैट इज साइटेशन स्टाइल को कैसे चेंज करते हैं. टाइप editor.citationstyles.org in the browser. For example, you can note it down. This is very important. editor.citationstyles.org, and here you'll find this type of tabs. So either you can search it, because you're not required to search. If it is there, then Jetero will automatically do it. Here I'm just let you know how to create your self-designed citation style. For example, this is chapter, this is article. In place of this notation, what do you want? You want a number, 1 square time. And you don't want this and here. You want O and K, first author, then there. Just add it as you do in Word. Then you want this as italic. You want this within quotes. You want this thing in bold, let's suppose. You don't want these DOI files. So here you can create, don't want this year here. You want at the end, suppose 007. So I have created this citation style by my own, and I have to search. So you can see there's 30 citation styles results are there. So you can see that here and word is there. So here this word is there. So you can choose which is very much similar to that thing. So it totally depends upon you. For example, let me choose this. I hope that this is quite similar to it. So go and put view style. And this is the bibliography and this is the code. आपको कुछ नहीं करना है, आपको इसके बाद विजुअल एडिटर पे क्लिक करना है. And in this visual editor, you can see in place. Yeah, citation 2, citation 1. I want this of article. अब ये फर्स्ट साइटेशन मेरा आर्टिकल था, अब ये इस टाइप से आ रहा है. Now, what do you do? You can change here also. अब आपको कैसे चेंज करना है? For example, click on authors. Author name will appear. You want comma, separated by comma. If you don't want comma, then put space here. Your comma will appear. In name, delimiter is comma. Remove here. You can see that comma has been removed from here. If you want to put semicolon, between the authors, semicolon would be there. If you want to put a space, then you can see simultaneously space would be there. So in this way, you can create, for example, you want here from italic, you want bold, it will be bold. You want here italic and bold, it would be italic bold. Here you want to remove it, just delete it. Okay. And somehow you have created the format which you want, and then go to save style. And
Yeah.
you can save that style, for example. Okay, this style has already been conventionally named. Then save as button. Okay, download style. So APAs, usually these files are saved with the name of APA, .csl. And if you have downloaded this, in Jetaro button, you can just click on the Jetaro. In preferences, inside, if you can't find the style within the already existed, then you just click plus here, and the style which you have created, let's suppose it is in download section, and this is the APA. So this is the style 7th edition that has been created today, 6/30/25. Okay, and that you can. So in this way, you can generate your citation styles also. And in Jetaro itself, there is a button. In Jetaro itself, there is a button in the preferences which help you if you have a little bit idea about the programming, then you let's suppose this is a style editor. So here, if you have a little bit idea about the italic, so if you don't want italic, you want bold, you can put bold here, and likewise you can easily change the things in the coding also, and you can save that with your name also. So all this feature existed in Jetaro as well as self-citation. So I'm just briefly going through the Mendeley. We have learned many things about the Jetaro, and Mendeley is quite similar to that thing. So let me close this Jetaro file. For Mendeley, what you have to do, go to Google and put Mendeley. And here you will see Mendeley Reference Management software. This software is from the Elsevier, and this software is the little bit less popular than Jetaro, but somehow as a Elsevier is there, so it is very famous among the people with science background. Second thing, it doesn't support that Google Doc. Therefore, I told you much more things about the Jetaro. Third thing, 2 GB. There it is free up to 300 MB synchronization. Here it is free up to 2 GB. So more paper can be stored here. But the problem is here that you have to always, first of all, you have to create an account, then you have to install it. So accept all cookies. You can see that first of all you required something this appear. Then in Jetaro you are directly downloading it, but here you have to create your account. Then you have to sign in here. So let me sign in. My name, you can see my name appears, and this is the desktop. download Mendeley file manager. Button is there. Just click here. Then an extension will be downloaded. And that extension would be like this: Mendeley Reference Manager 2.3. Then click here and follow the steps which it gives. So if you follow the steps, similarly, this desktop will open. Okay, let me close it. See, just like Zotero, you have different citation styles also there. You can also get Mendeley citation style if you want from other, for example. Okay, here also you can put the annotations just like if I click here, if I want to comment here, you can put a sticky notes and this is more my work. So annotations would be here only. Apart from them, just like Zotero, you can put the folders files in that format, and you can easily extract the metadata as you are doing in Zotero. For example, see, this is the desktop. Here you can create your folder. For example, I have created demo 1. You can create your collection, just name, du, and put pick. Then this collection is created. Now it's open. So if I want to add a paper here, so let me show you how to add a paper here. Let me go to a file where I have put some paper. Let's suppose I'm putting this 2 paper. Just click in here and put it here. So you can see the progress, it's updating 100%, 100%. So वो कहाँ create हो गया था? Two reference generated, all references. So you can see that these 2 references I have just generated here. You can click here and you can move to DU. So you can see that the database that Zotero has created, that has been created by this thing also. So all the things are quite similar here also in tools. If you want a word plugin, just follow the process. You require to have a Microsoft account, and for web, you can install Mendeley Web Importer, for example, and get for Firefox for different. So each and everything is quite similar. So I hope that you have learned something from this session. So I am ready for the questions. If you have, please let me know.
Any question, please, participants?
Sir, there must be some fair usage policy regarding the capacity or the storage limits.
Yeah, I told you, if you use synchronization, then Jotaro has 300 MB and Mendeley has 2 GB. But that is only on synchronization, because Mendeley usually you require internet to log in, then to use plugin also. But in Jotaro, this is not there. So in standalone, you can use any size of the data.
Okay, sir. Thank you.
Any other question?
Sir, I have downloaded Mendeley and written some work on Word file and cannot synchronize the references.
You
Not
have.
able to synchronize.
Can you share us in the front so that I can check it? Or you can. So the problem is that you have a Word file, you have installed the Jotaro, and that Jotaro button is not there, or something else.
I have downloaded Mendeley. Jotaro I have not
Okay,
tried.
Mendeley.
Huh.
Okay.
Then I have created a file.
Okay.
And written something there, or just I was trying to do the referencing, but not able to see the Mendeley app there on the dashboard.
You will see if you have installed the Jotaro extension in references, you see Mendeley site. You're not going to see a extension here for Mendeley. In references, you are going to see this. But there also you have to follow certain steps. So that's why I told you about Jotaro. It's quite simple and readily usable.
Okay, sir, I will try.
Okay, my screen is not visible. Because you have many tabs like home, insert, design, layout, then references. In references, you will see the Mendeley desktop symbol. And from there, you can do the editable thing. Yes, please. Any other questions?
Any other question? So thank you, sir. Sir, your session was very informative and engaging and provided with valuable insights into organizing and managing references efficiently by practical tips and demonstration of Zotero and Mendeley. And I am confident that knowledge you have shared will be useful in our research and teaching. Thank you, sir.
Thank you, ma'am. Thank you.
So you all can leave, participant, all of you can leave now. I will share the feedback form ASAP in the WhatsApp group.
Ma'am, I have
Hello,
a
ma'am.
question.
I am also having one question if Sonika ma'am is here.
Anji,
I
I'm
have a
here.
question regarding मैम उसके लिए जो हमारी आज सबमिट करनी है हमें प्रेजेंटेशन तो मैम वो हमें माई क्लास में अपलोड करनी है ना?
हाँ जी, माई क्लास में आप चेक करिए, आपके लिए असाइनमेंट एक वहाँ पे करा गया है असाइन। आई
मैम वो
होप
तो हमने किया हुआ है FIP, तो वो हमें पता है कि हाउ टू अपलोड, बट वही मैं पूछ रही थी कि एक बार की कंफर्म हो जाए।
हाँ जी, आपको
आपसे।
वहाँ अपलोड करना है और फिर
मैम
आपने
फिर आज ही आया, आज ही कैसे करें बना के?
हमने तो बहुत दिन से बता रखा है आरती जी, पहले के जिस दिन सेशन हुआ था
हाँ ये तो, हाँ
और
वो
उसी
आपने
दिन
बता
बता
रखा है
दिया
कि
था
वो
कि 30th लास्ट डेट है अपलोड करने की, ये भी उसी दिन बता दिया गया था।
अपलोड का नहीं पता था, अब ये पता था कि देन आफ्टर 30th देयर विल बी प्रेजेंटेशंस।
अभी आई थिंक वी had made it very clear when
हम्म।
Darshan ma'am and
ओके।
Preeti ma'am were in the session that we have to upload it on 30th and first onwards presentation start होगी। देखिए this is just to avoid the bias because हम alphabetical order में करेंगे, so people who have whose names are at the end of the presentations will get higher, much more time।
ओके मैम,
इसीलिए
ओके,
ये
नो
बात
इश्यू,
है।
नो
मैम
इश्यू।
आज आज रात को कितने बजे तक सबमिट करना है?
आज कर दीजिए।
क्योंकि मेरा ही फर्स्ट प्रेजेंटेशन है।
हाँ तो आप कर दीजिए अनाम जी, जब तक आप कर सकते हैं।
मैम ठीक है मैम।
यस यस डॉक्टर कमलेश, आपकी आवाज बहुत कम आ रही है।
अपलोड करने का ऑप्शन तो नहीं आ रहा।
आपने माई क्लास में आज चेक किया है? अभी 12 साढ़े 12 बजे आया है उसमें असाइनमेंट।
मैम असाइनमेंट है बट हम लोग अपलोड कर सके उसमें कोई ऑप्शन नहीं है ऐसा शायद ना।
ओके लेट मी चेक बिकॉज ये
नहीं नहीं मैम, ऑप्शन
जीएडी
है।
वालों ने अपलोड
देर
कर
इज ऑप्शन फॉर सबमिशन ऑल्सो। नीचे थोड़ा सा स्क्रॉल करेंगे तो नीचे ऑप्शन है फॉर सबमिशन।
मैम सबमिशन का ऑप्शंस कहाँ है? वो तो लिस्ट आई है मैम सिर्फ प्रेजेंटेशन
नहीं
की।
नहीं नहीं, यहाँ नहीं, आप माई क्लास में जाइए। माई क्लास पे जहाँ पे असाइनमेंट आपको असाइन हुआ है वहां जाइए, उसमें जब आप नीचे एंड में स्क्रॉल करेंगे असाइनमेंट में, वहां पे आपका सबमिशन का आएगा ऑप्शन जहाँ आप सबमिट कर सकते हैं अपनी असाइनमेंट।
तो असाइनमेंट्स में प्रेजेंटेशन को सबमिट करना है जो हमें कल प्रेजेंट करना है।
जी
ओके मैम। मैम हाउ इट कैन बी पॉसिबल आफ्टर गिविंग द presentations we will submit it?
No, you have to submit it today and then you can give the same presentation.
Yeah, I can understand, but ma'am, you
The
have
last, see, everyone should be ready on the same time. That is why 30th has been given, because those submitting late or those presenting later, we do not want that you should feel कि मेरा तो पहले दिन हुआ, मुझे कम time मिला, उनको ज़्यादा time मिला. To avoid that, everyone has to submit today, and then you can start presenting from tomorrow.
Okay, ma'am. How much time up to due time, ma'am? Today?
End of the day.
No, end of the day around 11 p.m.
Yeah,
or
yes,
12
yes,
p.m.
yes, you can do it.
Okay, okay. Thanks a lot, ma'am.
Okay. कमलेश जी आप कुछ कह रहे थे, डॉक्टर कमलेश, I couldn't hear you.
मैं ये कह रही थी कि आपने शायद उधर से